Hello students, welcome to the Gate Academy. I am welcoming all of you for this digital circuits marathon session. I hope previously all of you enjoyed the session. In the morning we have discussed 12 to 3, we conducted one session, right? So we are having one more session from now to up to 9 o'clock. We are having one, this is the second session for today. So I am welcoming all of you for this live session. All of you please share this video link with all of your friends so that they also will, they can attend this session in live and they also will get benefited from this session. Yeah, very good evening one and all. So in the previous session we have discussed, in the last question we have discussed this one regarding multiplexers, right? So in this particular session we are going to discuss few more questions related to multiplexer concept, and then we'll discuss regarding sequential circuits, and then we'll discuss microprocessor, and then followed by quiz. Okay, so all of you please actively participate in this session. This session is very much helpful for all the students who are from EC, electrical, instrumentation and computer science, right? All of you please quickly share this video link with all of your friends. So we'll start the session. Any doubts are there regarding previous session? All of you please respond. Okay, I hope no doubts. Okay, right. Yeah, this is the question asked in GATE CS 2007. They have given one multiplexer based circuit diagram and they have already given the output expression, right? So in this case you have to choose regarding x1, x2, x3 from the given 4 choices. From the given 4 choices you have to pick the correct one. Yeah, very good Nikita, no doubts. Okay. So if you are having any doubts regarding this particular session, whatever the concepts we are explaining, okay, you can make a note of all those doubts. Okay, at end part of the session I will clear all of your doubts. So all of you actively participate, okay, whenever we are discussing questions, right? So I will give some time for you to solve. After that, whatever the answers you are getting, please respond in the chat. So in this particular session, whoever actively participating, actively responding in the chat, okay, I will select 3 students, okay. For those 3 students you will get our test series freely. So this is the gift on Engineers Day. So all of you actively participate, okay. So what is the answer? See here, most of the students in general they used to do mistake. See, up to previously whatever we have discussed regarding mux, okay. So whenever you are having 2 by 1 mux, whenever you are having 2 by 1 mux, if the selection line is 0, if the selection is 0, I0 will be converted to the output. If the selection is 1, I1 will be converted to the output. Here in general we will put 0 here, 1 here, but in this particular circuit they have given volta. They put 1 here, they put 0 here, okay, but always the mux functionality will be same. Whenever the selection is 0, I0 will be converted to the output. Whenever the selection is 1, I1 will be converted to the output, okay, no matter where they represent regarding 0 and 1, okay. So first write the standard equation regarding 2 by 1 mux output. Okay. So if you are having single selection line, for 2 by 1 mux you will be having single selection, right? If the selection is 0, I0 will be converted to the output. If the selection is 1, I1 will be converted to the output, right? So for the time being, I am labeling output of first mux is say Y1, okay, Y1. So here you are already having the choices, right? So regarding x1, x2, x3, let us verify option by option, okay. So for the time being, I am considering option A. Whether it is correct or not, let us see. So here in the place of x1, you are having B. So here selection is B. So that means B bar into I0 plus B into I1. Okay. So in this case, I0 is B. I0 is B. I1 is A. Most of the students in the exam in hurry, they used to consider this as I0, this as I1, because in general we used to represent I0 here, I1 here, but in this question they have given the twist. They represented I0 here, I1 here, okay, right. So here B bar into B is 0, so that means you are getting AB. You will get A and B, A and B, okay. Of course we got Y1 as AB, but our requirement is we should get AB here, okay. Whether we are getting AB here or not, let us see. Let us continue further. So the final output I am considering as Y2. Y2. In this case, selection line is x3. X3 is A. So that means A bar into I0. I0 is what? I0 is x2. X2 is nothing but 0. 0 plus selection line is A into I1. I1 is nothing but Y1. Y1 is nothing but AB. So for the timing, I am writing Y1. Okay. First term anyway you will get 0. Second term A into AB. A into AB, that is nothing but AB, AB, right. So that means you are getting AB, okay. So option A is the correct one, option A is the correct one, okay. Those who consider I0 here, I1 here, okay, you may get wrong answer, okay. You have to be very careful. The mux functionality is always decided by the selection line, right. If the selection is 0, I0 will be converted to the output. If the selection is 1, I1 will be converted to the output. Okay, no matter where they have represented. I hope it is clear for everyone. If you are having any doubt, you can ask. Okay, we'll proceed to the next one. This is the question asked in GATE EC 2014. They have given the circuit diagram based on multiplexers like this, and they are asking the final output expression. See, regarding multiplexers, sometimes they will ask what is the final output, either in the SOP form or sigma m format, or sometimes they will give the output, they will give the selection values, they will ask the respective input combination, etc. Right. So these are the variety of questions regarding multiplexers. If you know the standard functionality, standard equation of multiplexer and functionality of multiplexer, you can easily solve any question related to the multiplexer. Whenever you are having cascading like this, so at each and every stage you have to write the output expression. From there only after that you can continue further. So from there you will get the final answer. Okay. Sometimes they will give only single mux, sometimes like this they will give, like one stage output they are giving as input for next stage, like this. What is the answer? These are 2 by 1 mux only, right? It won't take much time. So for the timing, I am assuming output of the first mux is say F1. F1. F1 equal to, here in this case selection is what? S1. So S1 bar into I0. I0 is here W. W plus the selection line is S1 into I1. I1 is what? W bar. I1 is W bar. Now if you carefully observe, here S1 bar W plus S1 W bar, that is nothing but what? Exclusive OR operation, right? S1 exclusive OR W. S1 exclusive OR W. Just carefully observe here. Here you are having 2 by 1 mux, you are having selection line S1, inputs are what? W, W bar. So here what you got? F1 as exclusive OR among these two. Yes or no? Exclusive OR among these two. Similarly, if you observe here, you are having similar kind of structure here, right? I0 value is F1, I1 value is F1 bar, F1 bar. Here you are having selection line. So now what is the final output? See here W exclusive OR S1 you got. Now in this case what you will get? F equal to exclusive OR operation among these two. F1 exclusive OR sorry, this one is S2, sorry, F1 exclusive OR S2, right? Now substitute in the place of F1 this one. So you will get exclusive OR operation among selection lines and W, right? So that means option D is the correct one. Exclusive OR operator will satisfy commutative law. You can interchange the order of the variables, okay? You can perform XOR operation on any two variables first and then with third variable. Yes, very good Nikita, option D is the correct one. Here this is S2, here you are having S1. Yeah, very good, very good. Now we are having the last question regarding multiplexers. This is a very interesting question which is asked in GATE EC 2016. So they have given the circuit diagram like this, okay, right. So they have mentioned delays of NOR gate, multiplexer and inverter are 2 nanosecond, 1.5 nanosecond and 1 nanosecond. They have given NOR gate delay as 2 nanosecond, mux delay as 1.5 and inverter delay, inverter or NOT gate delay as 1 nanosecond. Okay, what they are telling, here you are having 5 inputs P, Q, R, S and T. All the 5 inputs if you are applying at the same time instant, say for example at 0 nanosecond, okay, you have applied all the inputs at the same time, right? So what is the maximum propagation delay? What is the maximum propagation delay? See, final output you are getting here, right? After applying the inputs, in order to get the valid output, what is the maximum propagation delay that is taking? That is the question. So just read the question carefully and look at the circuit diagram and share your answers in the chart. This is a very interesting question which is asked in GATE EC 2016. So here the selection line is 0, here also the selection line is 0. Sorry, I0, I1, I0, I1. Selection lines are here S0, here S0. Yeah, very good Nikita. Answer is 6 nanoseconds. Yes, very good. So here if you observe, they have given the delays of each and every component present in this circuit diagram. Okay, right. So, but if you want to get the correct answer, you have to apply the mux functionality. Okay, but in general, most of the people, okay, while attempting this question, they used to forget the mux functionality. Up to now, we have discussed so much regarding mux functionality. The which input has to be converted to the output, that is based on the selection value, right? But for this question, most of the students in general in the exam, they used to forget completely the mux functionality. So because of that, they will come up with they will end with the wrong answer. Okay, so what kind of mistake they used to do, okay, I will highlight here, and how you can overcome I will discuss. Okay, right. See here, here mux functionality is decided by the selection line, right. So for the timing, let us consider case 1. Case 1, if you are considering, see, for the timing I am considering selection as 0. If the selection is 0, that time I naught will be converted to the output, I naught will be converted to the output, okay. But here what you are having, NOT gate, here 0 you are applying, so that means in this case you will get 1 as the output. So for this particular mux, selection is 1, so that means I1 will be converted to the output, I1 will be converted to the output. So that means all these inputs when you applied at the same time instant, okay, from the input to output, the propagation of the signal path is like this, NOR gate, then mux, like that, okay. So in case 1, t equal to 0 I have considered. So here NOR gate delay, mux delay, mux delay. So NOR gate delay they have given 2 nanosecond, mux delay 1.5, once again mux delay 1.5. So that means 1.5 plus 1.5, 3 plus 2, that is 5 nanoseconds. When you consider t value as 0, that time from input to output the propagation delay is 5 nanosecond, right. Now let us consider another case, that is t equal to 1. Now I am considering selection line as 1, okay, or t value 1. In this case selection line is 1, okay. So that means I1 will be converted to the output, I1 will be converted, but here you are having NOT gate, complement of 1 is 0. In this case I naught will be converted to the output, I naught will be converted to the output. So that means when you are making t value as 1, the propagation path from input to output is like this. Here NOT gate delay is 1 nanosecond and mux delay is 1.5, and here NOR gate delay is 2 nanoseconds and once again mux delay is 1.5. So just add all this, 1.5 plus 1.5, 3, 1 plus 2, 3, 3 plus 3 is 6 nanosecond. When you are considering case 2, when you are considering t equal to 1, that time you are getting 6 nanosecond. So here in case 1 you got 5 nanosecond, in case 2 you got 6 nanosecond. Here the question is what? Maximum propagation delay they are asking. So among these two, 6 is the maximum, so obviously 6 will be the correct answer. 6 will be the correct answer for this question, right. So here if you observe, because of this inverter, okay, you are getting answer as 6 nanosecond, okay. Suppose if inverter is not there, directly t input is connected here also as selection line, okay. Then if the selection is 0, here I naught will be connected, here also I naught will be connected. If the selection is 1, here I1 will be connected, here also I1 will be connected, okay. So if you observe like this, for case 1, 2 nanosecond plus 2 nanosecond, 4 plus 3, that is 7 nanosecond, okay. Another path is what? 1 plus 3, that is 4. So among 4 and 7, 7 is the maximum, right. So most of the students in general in the exam they used to mention 7 as the answer, but that is not correct. That is not correct for this question, but that will be correct if inverter is not there. If directly T line is connected as selection line for both the muxes, then 7 will be the correct answer, okay. Now some students might be having the doubt, why I haven't considered, see I have considered remaining all the components delays, but I haven't considered this NOT gate delay. Why I haven't considered? Any idea? Why I haven't considered this NOT gate delay? Why I haven't considered this 1 nanosecond delay? See, if you carefully observe, say for example, when you apply t equal to 0, okay, here in order to get 1, it is taking 1 nanosecond delay, 1 nanosecond delay, right. Now, here you are having 1, okay, so that means here I1 will be converted to the output, okay, but when this particular output is available, so in this case 1 nanosecond plus 1.5, so that means 2.5 nanoseconds, right. So you have to wait up to this time, okay, then only here input will be valid, so accordingly you will consider the mux delay and then you will get the output, okay. So now carefully observe, you are having two parallel paths, okay, here the selection value is 1 at 1 nanosecond, but you have to wait up to this particular input, that input you are getting at 2.5 nanosecond. So if you are having the time frame like this, say for example this is 0 nanosecond, here you are having 1 nanosecond and here you are having 2.5. So if you are already waiting up to 2.5, so that means this 1 nanosecond delay is already taken care of, right. Similarly you can verify for other case also, so there also it is already taken care, okay. When you consider t value as 1, here selection is 1, here you will get 0, so that means here I0 will be counted. I0 in order to get, here what you are considering 1 nanosecond, 1.5, 2.5 plus 2, that is 4.5 nanosecond, right. So already this 1 nanosecond is taken care of, okay. 1 nanosecond plus 1.5, 2.5 plus 2, 4 nanosecond. When you are waiting up to 4.5 nanosecond, so in that time frame itself this 1 nanosecond is already taken care of, right. So those are parallel paths, okay. So you no need to add this 1 nanosecond separately. I hope it is clear for all the cases I have discussed, okay. The answer for this question will be 7 if there is no inverter, if there is a direct connection between the two selection lines of these two muxes, then answer will be 7. But for this question the answer will be 6, okay, right. So with this we have completed regarding fourth chapter, that is combination circuits, okay. Now let us move on to the next chapter, that is sequential circuits. So regarding sequential circuits, first let us start with flip-flops. So we are having 4 types of flip-flops. One is SR flip-flop, second one is D flip-flop, third one is JK flip-flop, and fourth one is T flip-flop. So for these 4 flip-flops, you have to remember the characteristic equations. If you remember the characteristic equations of these flip-flops, okay, you can solve any question related to the flip-flops, okay. So just write down the characteristic equations. For SR flip-flop, characteristic equation is, one second, Q of t plus 1 equal to S plus R bar Q, S plus R bar Q. Q of t plus 1 equal to S plus R bar Q. Is this color visible for all of you? Is there any issue regarding this color? Shall I change the color? Is it visible? Okay, if you are having any issue with this color, please mention in the chart, I will change the color. Okay. So regarding D flip flop, characteristic equation is Q of t plus 1 equal to D. Regarding JK flip flop, the characteristic equation is Q of t plus 1 equal to JQ bar plus K bar Q. JQ bar plus K bar Q. Then T flip flop, characteristic equation is Q of t plus 1 equal to T exclusive R Q. T exclusive R Q. Right. So these are the characteristic equations of these 4 flip flops. If you remember these characteristic equations, okay, it is more than sufficient. Regarding flip flops, you will get the questions like this. Okay, they will give one flip flop, and with the help of other circuit diagram, okay, either through some feedback mechanism, okay, they will make some connections and they will ask what is the overall circuit. What is the overall circuit? You have to identify. The resultant circuit will be one among these 4 flip flops only. Okay, and whatever the questions, okay, based upon 2 flip flops or 3 flip flops, whenever cascaded configuration or in any fashion, right, you can solve those type of questions also with the help of tabular form method and by using these characteristic equations only, right. These equations are very easy, you can easily remember. Okay, if you are able to remember these 4 equations, it is more than sufficient for solving any type of the question related to flip flops. Okay. This is a question asked in GATE EC 2000. They have given one sequence circuit like this and they are asking the resultant circuit. Okay, they have given the choices like this. 2 choices they have given as SR flip flop, 2 choices they have given as JK flip flop, and regarding inputs they have mentioned like this. So you have to choose one among these 4. So for solving these type of questions, it is very simple. First, what you have to do, whatever the given flip flop is there, see in this entire circuit diagram they have given one flip flop, that is D flip flop. Okay, first write the characteristic equation of the given flip flop. So here characteristic equation of D flip flop is Q of t plus 1 equal to D. Q of t plus 1 equal to D. But here D value you have to find out. You have to find out. Now if you carefully observe, here you are having AND gate, one input is Y, another input is what? Q bar, another input is Q bar. Okay. Now, so that means here you will get Y into Q bar, Y into Q bar. Now, here you are having bubble. Whenever you are having bubble, if you are not comfortable with that bubble at the input side, just replace that one as simply like this. You are having one inverter or NOT gate, simple. If X is the input, output you will get X bar. So that means for this AND gate, one input you are applying as X bar, like that. Another input is what? Q. So here you will get X bar Q. Here you will get X bar Q. Okay. So here you are having OR gate. So just add these two. Just add these two, right? So that means here what you will get? X bar, I am writing like this, YQ bar plus X bar Q. y q bar plus x bar q. Now this equation if you compare with our standard equation of what, jk flip flop, then this is what, j q of t plus 1 equal to j q bar plus k bar q. So that means here x equal to k, y equal to j. Q of t plus 1 equal to j q bar plus k bar q. When you compare both the equations, here y equal to j, x equal to k, right? So if you look at the given four choices, so here y equal to j, x equal to k, y equal to j, x equal to k, so that means option D is the correct one. Option D is the correct one. Yes, very good Nikita, very good. So in this way you can solve easily any question related to the flip flop. First you have to write the characteristic equation of given flip flop, and then for D flip flop or T flip flop you will be having only one input. Okay, you have to find the corresponding input from the given circuit. Okay, whereas for SR flip flop or JK flip flop you will be having two inputs. Both the inputs you have to find and then substitute and do the simplification, and after doing further simplification, what are the equation you are getting, you have to just compare with the four standard equations of the flip flops. So to whichever equation it is matching, obviously that will be the correct one. Okay, you have to choose accordingly from the given four choices, like that. Okay. Next question, which is asked in GATE W 2013. So here they have given one circuit diagram like this, and they have mentioned the clock signal frequency as 1 kilohertz. Here they are applying the clock signal. So regarding clock signal frequency, they have given 1 kilohertz, and they are asking the frequency at Q, in kilohertz they are asking. Okay, so for the time being, whatever the question they are mentioning here in the three lines, for the time being just ignore. Okay, whatever the concept just now I have discussed, follow the same approach. Here you are having one flip flop, here you are having some circuit diagram. Just write the characteristic equation first and then substitute t value and do the simplification. From there, what is the final equation you are getting, tell me. After that you have to do one step extra. Okay, that anyway I will explain. So whatever the procedure earlier we have discussed, everything you have to follow. After that, instead of asking at that stage, they have asked one step extra, that's all. All of you try to solve. Just tell me what is the t value. Just tell me what is the t value. First write the characteristic equation of t flip flop, that is q of t plus 1 equal to t exclusive or q. Q of t plus 1 equal to t exclusive or q. Now just find the t value. Just find the t value. See here, if you carefully observe, you are having XOR gate, here XNOR gate, right? So if you carefully observe, here for XOR gate inputs are what? Q, Q bar. Q, Q bar are the inputs. Okay, right. Similarly here for XNOR also the same inputs they have connected, right? Q, Q bar. Now when both the inputs are complement to each other, XOR gate will produce output as 1. When both the inputs are complement to each other, XNOR gate will produce output as 0. Output as 0, right? So here NAND gate you are having, so 1 into 0 is 0, 0 bar is 1. 0 bar is 1. Okay, so that means t value is 1. Just substitute here t value 1, so that means 1 XOR q, that is nothing but q bar. That is nothing but q bar. So what you got? Q of t plus 1 equal to q bar. Okay, right. Very good Aswin, very good. Yeah. So that means what? See here flip flops are what? Edge sensitive devices. Edge sensitive devices. See whatever the equation you got, that particular operation will take place only here in this particular symbol, in this particular circuit. If you observe, you are having bubble. Bubble means what? Negative. Here edge symbol is there. That means whenever clock signal changes from 1 to 0, that time only your output will be complemented. Your output will be complemented. So here they have mentioned initial output is 0. Okay. Now, so I will draw the waveform. Just 1 second. Yeah. So we got the characteristic equation like this finally after doing simplification, q of t plus 1 equal to q of t whole bar. Okay, right. So first I am drawing the clock signal waveform. You can draw the periodic square waveform. Okay. Now regarding q waveform, let us draw. Before that, okay. So in the circuit they have mentioned it is a negative edge. That means whenever clock signal changes from 1 to 0, whenever clock signal changes from 1 to 0, that time only your output will be next state will be what? Complement of present state. Complement of present state. So initially q value they have given as 0. Sometimes they will specify initial state, sometimes they won't specify. If they mention by default what is the value they have mentioned, we will consider. Whenever they don't mention in the question, by default initial state you can assume 0, right. So here 1 to 0 transition happening, that means negative edge clock signal you are applying to the flip flop. So that means your next state will be what? Complement of present state. So up to now you are having at 0 signal, so 0 will be complemented to 1. So in this particular state it will remain up to whenever you are providing next negative edge of the clock signal. So here you are applying 1 to 0 transition. So now this value will become 0, and once again this value will be at 0 as long as you apply once again 1 to 0 transition, right. So here in this case it will become 1. Now if you carefully observe here regarding this clock signal waveform, it is a periodic square waveform. Okay. Time period is nothing but raising edge to raising edge or falling edge to falling edge, both are same, right. So this is one time period, okay, and this is another time period. So if you carefully observe for this particular q signal, okay, it is a periodic waveform. It is a periodic waveform. Whatever the pattern here you are having, the same pattern will get repeated, right. So that means here for this q signal the time period will be what? 2 times clock signal time period, yes or no? 2 times clock signal time period. So if you take the reciprocal, then you will get the frequency fq equal to 1 by 2t. 1 by t you can write as f clock signal frequency divided by 2. In the question they have given clock signal frequency as 1 kilohertz and they are asking the answer in terms of kilohertz only. So 1 by 2 is 0.5 kilohertz. Sometimes they may ask the answer in terms of hertz, right. In that case answer will be 500. Okay. Whenever, especially either it is MCQ type or NAT type, okay, whenever they mention the units, okay, be careful with the units. Based on the units the answer will vary. Here in this particular question they are asking the final frequency at q signal in terms of kilohertz. So the answer will be 0.5. Okay, if they are asking in terms of hertz, answer will be 500. So that means option B is the correct one. Option B is the correct one. I hope it is clear for everyone. So these are the questions related to the flip-flops. Okay. Now let us discuss the next important topic of Sequential Circuits chapter, that is counters. Counters. So regarding counters, okay, according to GATE syllabus we are having 3 types of counters, right. So can you guess what are those counters? All of you please respond in the chat. What types of counters we are having in the syllabus? Whatever the counters that you know, just please mention in the chart. Yeah, we are having ring counter, then Johnson counter, and then ripple counter. Yeah, very good Nikita, very good Aswin. Yeah, ring counter, Johnson counter, ripple counter, right? So in the ring counter and Johnson counter we will use D flip-flops, whereas in the ripple counter we will use T flip-flops. Okay, so regarding Johnson counter, other name is twisted ring counter, twisted ring counter. See, in the ring counter we will connect D flip-flops, okay, in the cascaded form. For all the flip-flops we will give the same common clock signal. The last stage normal output we will give as a serial input for the first stage. So it is forming a closed form, circular form or ring structure. Because of that we have given the name as ring counter, whereas in Johnson counter, instead of normal output of last stage we will give the complemented output of last stage as a serial input for the first stage. So because of that, here we are giving another name as twisted ring counter. Okay, in the ripple counter we will use T flip-flops. Okay, here all the flip-flops are not having the same common clock signal. Output of one stage we will give as a clock signal for next stage. So that particular phenomena is called ripple phenomena. If you just recollect in the binary adder, okay, output of one stage we will give as input for carry, output of one stage we will give as carry input for next stage, right? So that particular phenomena is called ripple phenomena. When you are dropping a stone in the water, what will happen? The waves will be displayed, right? From one molecule will bombard with another, another molecule will bombard with another molecule, like that displacement will happen, right? So that particular phenomena is called ripple phenomena. So in the binary adders we are having ripple carry adder, okay, carry output of one stage we used to give as carry input for next stage, like that. Similarly in the ripple counter, asynchronous counter, okay, here the T flip-flops we will use, one stage output we will give as clock signal for another stage, like that. Okay, so according to that we have given the name as ripple counter. If you want you can write other name for this counter as asynchronous counter, because clock signal is not same for all the flip-flops that we are using here, whereas in these two counters the clock signal is same for all the flip-flops. Okay, so these two are the examples of synchronous, these two are the examples of synchronous, whereas this particular counter is example for asynchronous counter. Okay, see, it is very simple. What is the difference between synchronous and asynchronous? In synchronous means the moment you are applying either positive edge or negative edge, whatever based on the given circuit, okay, all the flip-flops will respond with respect to the edge, okay, whether it is positive edge or negative edge, that label will be there in the circuit. Okay, so the moment you are getting the respective edge of the clock signal, all the outputs will be affected. Okay, whereas here it's not like that. Whenever the respective edge of the clock signal for that particular flip-flop come, then only their output will be affected. Okay, right. And here you can call this particular counter as binary counter, binary counter, either it can be up counter or down counter, up counter or down counter. Here with the help of ripple counter you will get all the states, whereas in ring counter and Johnson counter we won't get all the states and we won't get in a particular sequence with respect to our binary order. Okay, right. So say for example if you are considering in the ring counter n bit case, say for example I am considering n bit ring counter, so you will be having n D flip-flops, okay, and the number of states you will get n states, number of states will be n. If you are having n bit ring counter, we require n D flip-flops. With the help of n D flip-flops we will get the number of states as n. Okay, in Johnson counter, suppose if you are having n bit Johnson counter, so here also we require n D flip-flops, but now can you guess what is the number of states you will get here in Johnson counter when you are having n D flip-flops? Can you guess what is the number of states? Yeah, you will get 2n states, right? See, double the number of states of ring counter. See, in the ring counter you are getting only 3, suppose, say for example, if I am considering only 3 bits, then with the help of ring counter you will get only 3 states, okay. But here with the help of 3 D flip-flops you can get 6 states. Yeah, very good Aswin. You will get 6 states. But whenever you are having binary, whenever you are having 3 bits, total number of combinations are what? 2 power 3, that is nothing but 8. Okay, all those 8 combinations you will get in the ripple counter or asynchronous counter or binary counter. Okay, so here if you are having n bit ripple counter, then we will use n T flip-flops and the number of states will be 2 power n. The number of states are 2 power n. 2 power n. Okay. So here we will get all the possible states. Okay, if you are using as up counter, it will start from all the bits 0, it will increment by 1 for each and every clock cycle, and it will reach to the maximum. After reaching to maximum, once again it will come back to the original state, like that. Similarly, other operation is down counter. Okay, right. So these are the counters we are having. So regarding each and every case, if you remember this data, you can solve the questions related to this concept easily. Okay, right. And there is one more terminology we will use, that is mod n counter or modulus of a counter. Mod n counter. So this wording they will specify in front of any counter. In front of any counter they can mention the mod value. Okay. Here n indicates number of states. Here n indicates number of states. Number of states. Okay. So suppose for a mod n counter you are giving input clock signal frequency as f clock. So the output frequency you will get f clock by n. F clock by n. This is the output frequency. Okay. Similarly, if you are having ring counter, the number of states are n. If input clock signal frequency is f clock, in the denominator you will get this number. Okay. Whereas in the Johnson counter you will get this number as the denominator. In the ripple counter you will get this number in the denominator, like that. Okay, right. Now this is the example question regarding counters. The number of flip-flops needed or required for a mod 16 ring counter. For a mod 16 ring counter is. All of you quickly respond. They are asking the number of flip-flops required for a mod 16 ring counter. Yeah, most of the students are telling 4. See, just now we have discussed, right? Yeah, very good, Nikita, very good. See, in the ring counter, number of bits, number of flip-flops, all are same. In the ring counter, number of bits, number of flip-flops, number of states, all are same. Number of states, all are same. See, here you are having mod 16. Here 16 indicates what? Number of states. In the ring counter, number of states, number of flip-flops, number of bits, all are same. That means here the answer is 16. Here the answer is 16. Suppose if they ask, the same question for mod 16 Johnson counter, what is the answer? Suppose if they ask the number of flip-flops required for mod 16 Johnson counter. Now tell me what is the answer for this question? For mod 16 Johnson counter. See, this particular term they can introduce in front of any particular counter, but always this particular number indicates number of states only. Number of states only. Yes, very good Nikita, Aswin, very good. See, in the Johnson counter, here you are getting 16 states, okay, but how many flip-flops you require, okay. So here 16 is the number of states, so number of flip-flops required in Johnson counter, number of flip-flops required will be what? Number of states divided by 2. Number of states divided by 2. So here number of states are 16, 16 by 2 is 8. 8. Okay, if the same question, instead of ring counter, instead of Johnson counter, if they mention ripple counter, then what is the answer? For mod 16 ripple counter, how many flip-flops we require? See, whenever the term ripple is there, that is nothing but binary counter, right? So in the binary counter, either you consider up counter or down counter. Say for example, here number of states are 16. If you are considering up counter, the states will start from 0 to 15. Or if you are considering down counter, 15 down to 0. 15 down to 0. So either you consider 0 to 15 or 15 down to 0, 15 is the maximum, right? For representing 15, we require 4 bits. For representing 15, we require 4 bits. 4 ones is nothing but 15, right? So that means we require 4 flip-flops, 4 T flip-flops. See, in ring counter and Johnson counter, we will use D flip-flops. In the ripple counter or binary counter, we will use T flip-flops. Okay, so here the answer is 4. So whatever most of the students mentioned earlier 4, that 4 is the correct answer for this question. Okay, whereas for ring counter, number of states, number of bits, number of flip-flops all are same. In the Johnson counter, number of flip-flops will be half of the number of states. So the answer is 8. Here in the ripple counter, answer is 4. Now it is clear for everyone. I hope you will never do mistake in the gate exam, okay, regarding any particular counter. Okay, what is the minimum number of flip-flops? Okay. Next question, which is asked in gate W 2015. They have given one circuit diagram like this using JK flip-flops, okay, and they have mentioned initial state as 0 0, and they are asking the state Q1 Q0 immediately after 333rd clock pulse. See the beauty of the question. They are asking immediately after 333rd clock pulse. Okay, so whenever you are getting such type of questions, first what you have to do, whatever the given circuit diagram they have given, first of all you have to find what is the mod value for this particular question. That means how many states this particular counter or circuit is getting repeated. Okay, once if you know that mod number, after that we will discuss what is the status you are getting after 333rd clock pulse. Okay, now just look at the circuit diagram. Sometime when you are looking at the circuit diagram, you may feel that is a very complicated circuit diagram or like that, but if you carefully observe, you can solve these type of questions just like that. Just carefully observe. Here J0 is what? Q1 bar. J0 is Q1 bar. K0 is Q1. K0 is Q1. Okay. Now here J1 is Q0. K1 is Q0 bar. K1 is Q0 bar. Okay. Just observe carefully. Here you are having two flip-flops. Both are JK flip-flops. Both are JK flip-flops. JK inputs are complement to each other. JK inputs are complement to each other. If JK inputs are complement to each other, then JK flip-flop will become which flip-flop? If JK inputs are complement to each other, then JK flip-flop will become which flip-flop? I am given the clue. In the SR flip-flop, if S input, R input are complement each other, then SR flip-flop will become what? D flip-flop, right? In SR flip-flop, if S input, R inputs are complement each other, then SR flip-flop will become D flip-flop. In a similar way, in the JK flip-flop also, if J and K inputs are complement each other, then JK flip-flop will become D flip-flop. D flip-flop. Okay. So this is one D flip-flop, this is another D flip-flop. So what is the characteristic? So, and one more observation. For these two flip-flops, you are having the same common clock signal. Clock signal is same. Okay. Clock signal is same. So you can represent for the time being positive edge. Okay. Right. Clock signal is same. Right. So that means what? This is the synchronous sequence circuit. Synchronous sequence circuit. Whenever the respective positive edge of the clock signal come, okay, whatever the input here you are having, it will come here. Whatever the earlier input you are having, it will come here. That is simply D flip-flop. That's all. Okay. So that means simply you are having two D flip-flops which are connected in this fashion. That's all. Right. So actually, they have framed the question with the help of JK flip-flop. They are just misleading you. That means, while you are solving in the conventional approach, it will take more time. Okay, if you want to solve the same question in less time, if you observe the connections, from there you can visualize these are JK flip-flop, but if you observe these proper connections, then JK flip-flops will become D flip-flop, right? Okay. Now, and one more observation, if you observe, this is one D flip-flop, this is another D flip-flop. The output of this stage we have given as input for next one, and here complement output of this stage we are giving as what? Input here. Just one second. Yeah, just one second. Yeah. So here if you observe, you are having complemented output of this stage we are giving as serial input. Complement output of this stage we are giving as serial input. So now can you guess what is the counter? What is this counter? Can you guess what is the counter? We have discussed three counters, right? Ring counter, Johnson counter and ripple counter. Among these three counters, the resulting circuit is which counter? Yeah, very good Nikita, very good. See, the resulting counter is what? Johnson counter. See, in the Johnson counter, the complement output of last stage we will give as serial input, right? So this is simply Johnson counter, 2-bit Johnson counter, that's all. Yes, very good Aswin, very good. It is a 2-bit Johnson counter. See, the beauty of the gate question is this one. Whatever the concepts are there, you should be fundamentally strong. Then, instead of directly asking the name, they are specifying 2-bit Johnson counter. See, if they specify, the question is nothing, right? So you have to visualize from the given circuit. Okay. So if you carefully observe and visualize, from there you come to know that this is a 2-bit Johnson counter. Once if you identify this particular counter is 2-bit Johnson counter, after that this question is nothing. But if you are unable to visualize this is a 2-bit Johnson counter, definitely it will take more time for solving this particular question. Okay. Okay. Right. So always whenever you are getting any question related to sequence circuits, just observe the given circuit and try to visualize whether we can do the simplification in the mind level or not. If there is a possibility, do that one. Okay. So that your simplification will become easy and you can get the correct answer in less time, right? Okay, right. So this is the 2-bit Johnson counter. So in the 2-bit Johnson counter, so this is the 2-bit Johnson counter. So when you are having 2 bits, so in this case we are having Q0, Q1. Q0, Q1 we are having. Initially they have mentioned 0, 0. So this 0 bar will come here 1, this 0 will come here. Next cycle 0 bar is 1, 1 will come here. Next cycle complement of 1 is 0, 1 will come here. Next cycle complement of 1 is 0, after that this 0 will come. So just for reference I am mentioning the clock number, just I am mentioning clock number. Whenever the respective positive edge of the clock signal will come, here that particular operation will take place, right? One state to another state transition will happen. 0, 1, 2, 3, 4. Okay. Now if you carefully observe, whatever the initial state you are having, when there is no clock pulse applied, the same state you are getting after applying fourth clock pulse. Or you can visualize like this: 0, 0, 1, 0, 1, 1, 0, 1. Here these 4 states only will get repeated. Okay. Either you can look at with respect to clock pulse number or with respect to different states. From there you can determine what is the mod value for this particular counter. So here we are having 4 different states, or whatever the initial state you are having, okay, how many clock cycles we require in order to bring the counter to the same state. Okay, either from here or from here you will come to know that it is the mod 4 counter. It is the mod 4 counter. Okay, it is the mod 4 counter. Now the question is what? After applying 333rd clock pulse, what is the state of the counter? Now you just do this operation, that's all. Whatever the clock pulse number they have mentioned, 333, divide that number with what? Whatever the currently you got mod number. Okay. So just perform the division. 4 8s are 32, remainder is 1. Here you can take 3, 4 3s are 12, remainder is 1. So in the remainder whatever you are getting, just consider that clock pulse number. Just consider that clock pulse number. So here the clock pulse number is 1. Okay. So after applying first clock pulse, whatever the state you are getting, the same state you will get after applying 333rd clock pulse also. That's why here the word mod indicates what? Whatever the remainder you are getting. See, if you want you can carefully observe like this. Here at 0th clock pulse you are having 0 0. Okay. After applying 4th clock pulse also you are getting 0 0. Right. So if you wanted to know after applying 4th clock pulse what is the state? Okay. So here the mod value is 4. You wanted to know after applying 4th clock pulse what is the state? 4 1s are 4, remainder is 0. So that means the denominator value is corresponding to what? Clock pulse number. After applying, when there is no clock pulse applied, what is the state you are having? The same state you will get after applying 4th clock pulse, 8th clock pulse, like that, right? For every 4 clock cycles you will get the same state. Okay. So here after applying 333rd clock pulse, what is the state of the counter? That is the question. So here when you do the division like this, here you got in the remainder 1. Okay. After applying first clock pulse, whatever the state you got, the same state you will get after applying 333rd clock pulse as well. So now can you guess what is the correct option among the given choices? Here you are having 4 choices, just pick the correct one. All of you please respond. Yeah, Meghna is getting C. Yeah, most of the students in the exam also they used to do mistake. These are the silly mistakes. These are the silly mistakes. See, here carefully you have to read. See, why I have asked you the same question. Here if you observe, after applying clock pulse, here you got 1 0, right? Straight away you can choose option C. But why I have asked that question? I thought you will read the question carefully. See, here what they are asking, the state Q1 Q0 immediately after 333rd clock pulse. Here they are asking Q1 Q0. See, after applying first clock pulse you are having Q0 Q1 as 1 0. Q0 Q1 you are having 1 0. So that means Q1 Q0 will be what? Order you have to just reverse, right? 0 1. So that means option B is the correct one. See, up to here also if you get the correct one, but if you don't read the question carefully, because of that you may choose option C, but the option C is wrong. Option B is the correct answer, right? So please avoid these type of silly mistakes in the GATE exam. Okay, no problem. Here in the class you can do silly mistake. Okay, don't get worry, right? But these type of silly mistakes don't do in the real GATE exam, because whatever the marks you are supposed to get, you are losing because of these negative, because of these silly mistakes. you will lose, right? There will be negative marking for each and every wrong answer, right? Especially for MCQ type of questions, there will be negative marking. For 1 mark question, there will be 1/3 negative marking. For 2 mark question, there will be 2/3 marking, negative marking, right? So be careful, okay? Always please cross check the question, what they are asking, what we have to choose, okay? You are very good at the concept, no doubt about it. You are very good at the concept, you got the correct only. But if you don't, if they ask Q0, Q1, then answer is 10 only, option C only. But they have asked Q1, Q0, right? So you have to be very careful, right? Yeah. Yeah, very good, Nikita, Meghna, Ashwin. Yeah, all you 3 people are actually participating, okay, right. So you 3 people are eligible for getting the our All India mock test series freely. So now you will get one Google form in the chart. So Nikita, Ashwin and Meghna, you 3 people can fill that Google form. So on Engineers Day, you got the gift from our side, that free test series. Congratulations to 3 of you. Nikita, Meghna and Ashwin. So in some time in the chart you will get the Google form. So please kindly fill that Google form in order to get the free test series. Thank you for your response. Actually participated. Yeah. Nikita, Meghna, Ashwin. So our test series are very much helpful for you. Whatever I just now told, okay, this is a silly mistake generally students used to do, right? So you can overcome those kind of silly mistakes, because in the whatever you will get the questions in the real GATE exam, if you are practicing, okay, you will get the environment, right? So whatever the concepts you know, when you are applying the concepts, okay, there you may face some difficulties, okay, you can overcome from each and every test. You can overcome whatever the mistakes you done, just write down somewhere, and those are the learnings, right? So from each and every test you can overcome some, okay, whatever the mistakes you done in test series 1, you can overcome in test series 2, like that, okay? So from each and every test series definitely you will learn lot of things I can say, okay? And if you are able to get the confidence from our test series, definitely in your real GATE exam you can peacefully and with confidence you can attempt the real GATE exam, and you can score more marks. Whatever the marks you are supposed to get, you can get easily without any tension, right? Yeah, please best utilize this golden opportunity whatever you got today, because you are fortunate to attend this session and actually participated. So because of that you got this gift, free test series for all, for Meghna, Ashwin and Nikita. Thank you, thank you. So kindly fill that Google form, just save that Google form somewhere and try to fill, okay, parallelly whenever you get some time in this session, try to fill, okay, right. Yeah, next question, this is the example question. They are asking they have given one circuit diagram like this, or block diagram you can say. They have mentioned 3 points here, point A, point B, point C. Okay, so you have to find the frequency at A, B and C. You have to find the frequency at A, B and C. So here for this particular counter, input clock signal frequency is F. Okay, that particular signal they have given as here input, the output of this one they have given as input for that one, like that. Okay, you have to just find FA, FB, FC. See here, whenever they specify mod n, right. So here input frequency is f, okay, f divided by number of states. Here n is 6, so that means you will get f by 6, f by 6. No need to do further simplification, like this is sufficient, okay, right. So here you are having 3-bit ripple counter. Whenever the term ripple is there, that means it is a binary counter, right. So here input frequency is fa. In the denominator, how many states you will get? You will get 2 power 3. Whenever ripple counter or binary counter is there, all the states you will get, right. So here number of bits are 3, so that means 2 power 3. Here input frequency is fa is f by 6, f by 6 divided by 8, that is what, f by 48, f by 48, f by 48. Now here you are having Johnson counter, 4-bit Johnson counter, right. Here output frequency is fc, input frequency is fb divided by, here number of states will be double of the number of bits, okay, 2 into 4. So here fb is nothing but f by 48, f by 48 divided by 2 4s are 8, okay. Don't do silly mistake here, 8 6 are 48, don't do such kind of silly mistakes. Here both are in the denominator only, so if you do the simplification you will get f by 384, okay, right, very good Smith, f by 384, yes. So here if you observe, whenever in the real time, whenever you are having very big digital system, okay, so there you will be having various modules, right, various digital circuits you will be having, okay. For the entire system, whether we can operate with the same clock signal frequency for whatever the modules we are having, is it possible? Need not be, right, it's not possible, because each and every circuit can be operated at different frequency, but for the entire system we might be having only one system clock like this, okay. So in such scenarios what we will do, with the help of various counters we can generate various frequencies like this, okay. So based on our requirement, okay, we can generate various frequencies and we can give these signals as the clock signals for those modules like that. So this is the real time application of counters, that is frequency division. Here frequency division operation is happening, right. So this is the real time application, okay. For all the circuits in the entire digital system we cannot operate at the same clock signal frequency. Each and every module can be operated at different frequency, right. So based on that requirement we can generate various frequencies with the help of cascading of various counters, okay, right. So these are the questions related to counters, okay. Now let us move on to the next topic, that is finite state machines. That is only part of the GATE syllabus for EC branch, okay, and after that we will discuss regarding microprocessor, okay. So these two topics we are going to cover about 45 minutes to 1 hour, okay, but even other branch students also please attend this session, don't leave this session, because once the microprocessor is completed, after that we are going to conduct one quiz, okay. So actively participate in that quiz in order to know your confidence level regarding this particular subject, okay. And whatever the concepts I am going to discuss regarding finite state machines and microprocessor memory interfacing, okay, somehow or other some concepts you can correlate, okay. Whatever the concepts up to now we have discussed, okay, sometime I may include these concepts as well there, right. If you are from any other branch, okay, you can skip whatever the two topics I am about to discuss, okay, for your exam point of view, but in this session you can attend, don't leave this session, okay, right. So regarding finite state machines, see actually here we are having different wording, that's all, finite state machine, but actually this is, I can say that this is the synonym for your sequence circuit only. See, if you consider any counter, what the main functionality, it repeats a particular states repeatedly, right, from one state to another state, state transition will happen. See, Whether any CS students are there? Who, just respond who are from CS, who are from EC, electrical, instrumentation. Just mention in short, EE, EC, IN, CS, like that. Just mention your branch in the chart. In short, you can represent. Yeah, Nikita, Meghna from EC. Okay, you are lucky. This concept is related to, is applicable for EC branch. Yeah, Smith is from instrumentation. Any CS student? Okay, no issue. See, in your BTech, you might have studied in your first year C language, right? So whenever you want to write the programming, what is the first step you used to do? Whenever you are writing your observation book before going for your laboratory, whenever you are supposed to write any program, what is the first step you used to do? Yeah, very good. We are having the students from EC branch, instrumentation branch. Okay. So all of you are having C programming, right, in your BTech first semester. So whenever your faculty asks, write a program, so what you used to do? There are two steps, right? Either you will write algorithm, that means step by step, what are the actions you are supposed to give the commands, okay? Or you can draw the flowchart. The representations are different, but ultimately either if you are good at algorithm or if you are good at flowchart, that is more than sufficient in order to write the best program. Circuits, whatever the based on the flip-flops, what are the circuit diagrams we have considered, that is one approach. And the same thing from one state to another state, when the state transition will happen. So regarding that, here in this particular concept, we will use the flow chart, simple logic, okay, or diagram, state diagram we can say, right? So that means this finite state machine is nothing but synchronous sequential circuit only. From one state to another state, when the transition will happen, okay, that particular thing we will represent in a pictorial form, right? And if that particular machine is having finite number of states, we can call that particular sequence circuit as, or that particular state machine as finite state machine. So regarding finite state machines, we are having two types of finite state machines. Can you guess what are those two types? Yeah, we are having Mealy state machine and Moore state machine, okay. So we are having two types of state machines. One is Mealy state machine and other one is Moore state machine, right? So whatever the sequence circuit depends on both present inputs and present state, right? So regarding Mealy state machine, that definition will applicable, okay. Here output depends on both present inputs and present state. See here, if you observe, whatever the circles here we have represented, and inside circle we have labeled as A, B, C. So these are like states, okay, right. And here if you observe, we are having the representation like this. So this is your input and this is your output. So for each and every case, whenever the arrow mark is there, on top of that there are two values. First one is correspond to input, second one is correspond to output. Yes, very good Nikita, very good. Okay, so here if you observe, say for example currently you are at this state, okay, now you are moving to this state, okay. So here output depends on both present input and present state. You can just observe, here you are getting output, right? From state A to state B, transition will happen when you are getting input as 1, that time only the state transition will happen, okay. And the output 0, output you are getting 0, that is based on what? Your present state and present input, okay. Like this, if you are having the state machine, then we will call it as Mealy state machine, okay, right. So here if you observe, from state A to state B, the transition happening if you are getting bit value as 1. Okay, here I am writing input bits received or input bits detected. Okay, right. So here we got input bits as 1 and here I am writing output we got 0. Okay, now from state B to state C, when the transition will happen? When you are at state B, if the input is 0, that time the transition is happening, right? So that means up to here you got 2 bits, 1 and 0, but still output is 0. Now currently you are at state C. If the input is 1, then output is 1 and it is moving to state B. Okay, so now if you observe here 1 0 1, up to here we got 1 0 as the inputs. Now we got one more input 1 and in this case we are getting output as 1. Now if you carefully observe this particular state diagram, what it is performing? It is detecting 3 bits 1 0 1. Whenever you are sending 3 bits 1 0 1, whenever you are sending series of bits, whenever you are getting the bits as 1 0 1, that time it will produce output as 1. So that means it is what? Sequence detector. Yes, very good Smith. So this particular state machine detecting 3 bits 1 0 1. Now regarding detection, okay, say for example, one second. Say for example we are having like this, I am giving like this 1 0 1 0 1. Okay, I am giving the same bits. Now there will be two possibilities. See, here when you are sending the bits from left to right, here you got 1 0 1. So that means here you will get output as 1. Okay, suppose if the sequence detector detecting the sequence with overlapping, suppose with overlapping means what? For first sequence ending bit can be the starting bit for the next sequence starting bit. Okay, so that means here also you will get 1. So that means if the sequence detector detecting sequence of bits with overlapping, so this is the case with overlapping. Okay, with overlapping, so 2 times you will get output as 1. For remaining cases you will get output as 0, right? Yeah, very good Smith, very good. Now suppose if it is without overlapping, suppose the sequence detector without overlapping, if it is detecting, then in that case here 1 0 1, here you got one sequence, output is 1. So here you won't get output as 1 because next sequence is starting from here, 0 1 only you are having, right? Okay, so that is the difference between with overlapping and without overlapping. Now tell me, this particular state diagram is an example for with overlapping or without overlapping? For which case this particular state diagram is an example? Either first case or second case? Which one? Just observe. See, if you are having any doubt, just you can give 1 0 1 0 1 like this as an input. So how many times you are getting output as 1? From there you will come to know. If you are getting for 2 times output as 1, that means with overlapping. If you are getting only for one case, that means it is without overlapping. Yeah, very good Aswin. It is with overlapping. See, it is very simple. You can just observe from here also. See, when you are at state A, if the input is 1, you are moving to state B, output is 0. Okay, currently you are at B state, input is 0, output is 0, state C. Okay, from state C, if the input is 1, it is coming here. So that means here output is 1. Fine, up to here it is clear. Now up to here it is clear. Now when you are at state B, if you are getting input as 0, that means output as 0. Okay, here you are getting output as 0. Okay, next, currently you are at state C, once again input is 1, output is 1. So that means here you are getting 2 times 1 So that means it is with overlapping, with overlapping. Yes, very good Nikita and Meghna. Yes, very good. Now if you want to make the same state diagram for without overlapping, now what modification we have to do? See, from state C to state B I have given the arrow mark. Now if you want to avoid this case, suppose if your requirement is without overlapping, then in that case what we will do, instead of like this connection, you have to make the connection from C to A. Then what will happen? 101 we have received, after that once again sequence is starting like that. Okay, right. I hope it is clear regarding Mealy state machine. Mealy state machine is nothing but whatever the definition is there regarding sequence circuit, exactly the same thing it is following, that's all. Okay, only thing there we will explain with the help of circuit diagram and tabular form, and here we are having the pictorial representation from one state to another state when the state transition will happen. Here output depends on both present state and present input. Okay, right. Now the next one is Murray state machine. Here in the Murray state machine, the output depends on the present state. Sorry, just one second. Yeah, in the Murray state machine, if you observe here, the difference between previous one and this one you can just observe. Previously on the arrow marks we are having input slash output. Okay, but here we are having only the inputs. This is the input, and previously in the circles we are having only states A, B, C like that. Okay, but here in the denominator it's not the denominator. Okay, just we are indicating like this. Okay, right. So this is the state A, state B, state C, state D like that. Here whatever the value here you are having, that is nothing but output. Now if you carefully observe, here output depends on what? Only present state. Here output is 0, output is 1. Here output you are getting 1 when the present state is D. So that means Murray state machine, what it is saying, if the output depends only on the present state, then that is an example of Murray state machine. Now can you tell me whether this is an example of sequence circuit or not? Here output depends on the present state. Output depends only on the present state. See, in the combination circuit, outputs depend only on the present inputs, whereas in sequence circuit, outputs depend on both present inputs and present state. Okay, so if it is depending on both present inputs and present state, it is sequence circuit. Even if it is depending only on the present state, still we can say it is a sequence circuit, because in a sequence the process is going on, right, from one state to another state like that. Okay, so this is also example of sequence circuit only, but part of the definition only we are considering here. Here outputs depend only on the present state. Output depend only on the present state, not on the present input. Are you able to visualize the difference between Mealy state machine and Murray state machine in the diagram? How we are representing, how the outputs depend on what conditions? Clear? Right. Okay. Now here also if you observe, this particular state diagram detecting what bits? All of you please respond. This particular state diagram detecting what bits? just observe here. Here you, if you are at state A to state B transition happening at the when the input is 1. Okay. In this case, you got output as 0. Okay. From B to C, the state transition happening when it is 0. So here also output is 0. Now C to D transition is happening if the input is 1. Here in this case you are getting output as 1. So that means this particular state diagram also detecting 3 bits, those are 1 0 1. Whenever you are getting 1 0 1, so that time it will produce output as 1. Okay, just like previous one, right? But if you observe the difference between previous one and this one, in the previous case also that particular sequence detector detects 3 bits 1 0 1 only. Here also it is detecting the same bits 1 0 1. But have you observed any difference regarding the state diagram? Regarding the state diagram, have you observed any difference? In the Mealy state machine, we are having only 3 states A, B, C, whereas in the Moore state machine, we are having 4 states A, B, C, D, right? So here in the Moore state machine, we may require more number of states. Okay, the relation between regarding number of states with respect to Mealy machine and Moore machine, the number of states of Mealy machine will be less than or equal to Moore state machine. Okay, right. Now this is also example of overlapping only. See, if you carefully observe, 1 0 1 you have received. After that, if the input is 0, it is coming here, and the next bit is 1, it is coming here. So that means it is also example for overlapping, with overlapping. Now if you want to make the same state diagram for without overlapping, what you can do, instead of the arrow mark from D to C, you can make the arrow mark from D to A, like that. Then that particular state diagram will be without overlapping. So based on the context, based upon your requirement, you can design either for with overlapping or without overlapping, like that. Okay, I hope it is clear for everyone, right? Now this is a question asked in GATE EC 2017. They have given one state diagram like this, okay, and they have mentioned it is detecting an overlapping sequence of 3 bits. See, they already given the clue. You no need to put so much effort whether it is for overlapping case or without overlapping case. If they don't specify, then you have to visualize, okay, definitely with carefully, but anyway they have given this clue in the question itself, okay, and they have mentioned how many bits it is detecting also. Okay, only thing you have to identify which bits it is detecting. Okay, this particular state diagram is correspond to the sequence detection of which bits. First you have to identify that one. After that, they have given the sequence like this. They have given the bit sequence like this. Okay, from left to right they are sending bit by bit. Okay, so for how many times output you will get as 1? That is the question. So if you carefully observe, just tell me first of all, this particular state diagram detecting what bits? First, all of you please respond. See, you can just observe from this diagram, right? Here you have received 1, okay, here you have received 1 0, here you have received 1 0 1. Now you are getting output as 1, right? Yes, very good Smith. So here this particular sequence detector detecting 3 bits 1 0 1, okay, and anyway they have mentioned with overlapping, right? So here you are having 1 0 1, so output is 1. Next, with overlapping, so the ending bit of first sequence will be can be the starting bit for next sequence, right? So 1 0 1 output is 1, next 1 0 1 output is 1, next 1 0 1 output is 1. So 4 times you will get output as 1. The answer for this question is 4. Yes, very good, Smith. Mohan, very good. Aswin. Yeah. So if they don't specify, then you will observe from the diagram whether it is overlapping or non-overlapping. Anyway, they have given the clue, right? So that's why sometime you may feel that from the state machines, okay, see the question length is very huge, right? Very lengthy question. But if you read the question carefully, already they have given the clues in the question itself, right? So you can solve these type of questions easily in less time, okay? In the GATE exam, for any subject, whenever sometime the question is very lengthy, okay, don't think that that is very complicated question we cannot solve, okay, don't assume like that, okay. Just give one reading, okay. After reading, just try to catch whatever the main keywords are there, and after that whatever the rest of the parameters or data they have given, just try to understand, and from there you apply whatever the knowledge you know, and from there you will get something, okay, definitely, okay. Sometimes intentionally they used to put very lengthy question, but for solving that question, whatever the hints are required, they will directly mention in the question somewhere, okay. So you can solve these type of questions just like that in the GATE exam, okay, just to, you know, just to divert you, okay. Instead of solving these type of questions, okay, they may put very lengthy questions sometime, okay, but don't get trapped, don't leave such type of questions. Just give one reading. After giving one reading, if you are comfortable, try to solve. If you feel that it will take more time, you can skip that question at that time. You can give one more time at last, okay, right. Yeah, with this we have completed regarding sequential circuits chapter. Now we will move on to the next chapter, that is microprocessor. Earlier, even microprocessor is also part of the GATE syllabus for EC branch and electrical branch, but from the last year, okay, from the recent GATE exam onwards, they have removed, okay, microprocessor from the GATE syllabus for EC branch and electrical branch. Currently, it is only part of the GATE syllabus for instrumentation branch, okay. So currently in this particular session, let us focus on 8085 microprocessor memory interfacing, okay. So before that, regarding 8085 microprocessor, okay, see any microprocessor you can consider, to the microprocessor you will interface the devices, right, like input device, output device, memory, etc. Input device, output device, memory, we will call it as peripherals, okay, right. So regarding 8085 microprocessor, we are having, can you guess how many address lines we are having, how many data lines we are having? Yeah, we are having 16 address lines, 8 data lines, okay. With the help of these 16 address lines, microprocessor will identify the peripheral which is interfaced to the microprocessor, and with the help of these 8 data lines, the microprocessor will transfer the data either from microprocessor to the device or from the device to the microprocessor, okay, right. So if you are having 16 address lines, then you will be having 2 power 16 possible values in terms of zeros and ones, right. Yes, very good, Aswin, very good. So if you are having 16 address lines, see here address lines are bits, both are synonymous, we can use, no issue at all, okay. If you are having single bit, we can represent either 0 or 1, like that. If you are having 16 address lines, we will get 2 power 16 combinations of zeros and ones, right. So this 2 power 16 we can write as 2 power 6 into 2 power 10. I hope all of you are very much familiar regarding the value for 2 power 10. What is 2 power 10? 2 power 6 I am writing it as 64. 2 power 10 is nothing but 1024, okay. In our day to day life, whenever we are having 1000 grams, okay, 1000 number is there, we used to represent as what? K, letter K, right? Similarly, in the binary, in the microprocessors, okay, whenever you are getting 2 power 10, we will represent as capital K. Okay, here actual number is 2 power 10 is nothing but 1024, it is almost closer to 1000, okay. So we will represent as 64K, okay. So say for example, if you are interfacing one memory device to the microprocessor, since we are having 16 address lines, okay, so it can suppose you are considering one particular memory device, okay, in that particular memory device it can identify 64K locations, 64K locations it can identify, and in each and every location you can store 8-bit data, you can store 8-bit data. So now you can write the memory capacity of 8085 microprocessor. See, sometimes students will misunderstand that inside microprocessor we are having the memory. No, inside the microprocessor we don't have the memory. Inside the microprocessor you are having only ALU, register array and control unit, right? If you are having memory also along with microprocessor on the single chip, we will call it as microcontroller, right? For the microprocessor, memory will be outside. That means you have to interface memory device to the microprocessor, okay, right? So regarding that particular memory device, I am telling the what is the maximum capacity that you can interface, okay, to the 8085 microprocessor. Here you are having 64K locations, and in each location you can store 8-bit data. So group of 8 bits we can call it as byte. So that means, just one second. Yeah, group of 8 bits we will call it as 8 byte. So that means we can write it as 64 kilobyte. So the maximum memory capacity that you can interface to your 8085 microprocessor is 64 kilobyte. 64 kilobyte. So this data is more than sufficient for solving the questions related to memory interfacing of 8085 microprocessor. Okay. So now let us solve the questions. Yeah, this is the example question. Here you are having 3 memory chips are of size 1 kilobyte, 2 kilobyte and 4 kilobyte. Their address bus is 10 bits. What are the data bus sizes of these chips? What are the data bus sizes of these chips? Yeah, see, whatever the memory capacity formula I have given, follow the same, okay. Whenever regarding memory size, memory capacity, all are synonymous, okay. You can write the formula memory size or memory capacity. Memory size or memory capacity. Generalized formula you can write like this. If you are having n address lines, with the help of n address lines you will get 2 power n memory locations, right, and in each location you can store m bit data. So the size of the memory or capacity of the memory is what? 2 power n by m. This is the general representation. Sometimes when we are multiplying together we will represent like this, okay, right. So here for these 3 memory chips the number of address bus size is same, 10 bits only. So that means n value is 10 only, okay. But here memory size is different, so accordingly the number of bits will change, number of data bus size will change, okay. So in the case 1 kilobyte you are having, k I am writing it as 2 power 10 into byte I am writing it as 8 bits, 8 bits, okay. For the time being, I am giving the answer in terms of bits. Okay, right. So is equal to 2 power n, n value is 10 into m1. For first chip, I am labeling as m1. Okay, number of data bits. So here 2 power 10 will get cancelled. So from here you will get m1 equal to 8 bits. m1 equal to 8 bits. See, similarly if you observe what is happening here 2 times, here 4 times, just multiply accordingly, that's all. So here m1 is 8 bits. So in the second case 2 into 8 bits, that is 16 bits, and last case 4 into 8, that is 32 bits. 32 bits. Okay, right. So this is the standard formula regarding memory capacity or memory size. If they ask the question in terms of bytes, for this question the answer will be 1 byte, 2 byte, 4 byte. If they ask the question in terms of bits, 8 bits, 16 bits, 32 bits, like that. Okay, always be careful with respect to units, in which units they are asking the answers. Okay, that is very, very important. This is the question asked in GATE EC 2001. Here they have given the memory size of a RAM like this, 4K by 8. See, whenever you are having the representation like this, okay, here 4K correspond to what? Number of locations, number of memory locations. Here whatever the number, if they are representing like this, okay, always this will be bits only. Okay, previously we have seen there is the capital B, that means byte. Okay, whenever they represent like this, always by default this particular data will be in terms of bits. Okay, and if you are having any doubt, from here also you will get the clue. Last byte. See, here you are having 4K memory locations. In each memory location you are storing 8-bit data. In each memory location you are storing 8-bit data, right? So group of 8 bits is nothing but byte. Group of 8 bits is nothing but byte. Okay, right. So here in this question they have given the starting address like this, and they are asking what is the ending address or the last address. Okay, so for the time being, let us consider this number. Okay, later we will deal about this particular number. Okay, right. So here 4K locations you are having. 4K locations you are having. So 4 I am writing it as 2 square, and K I am writing it as 2 power 10. Okay, so that means here you will get 2 power 12. So that means what? Here we require 12 address lines for this particular memory device. Okay, in order to interface we require 12 address lines. 12 address lines, right? So when we are having 12 address lines, we will represent, one second. Okay, so here we require 12 bits, right? So just put the labeling like this, 12 bits, you are having, right? So here we are having 12 bits. Okay, so the starting value will be what? You can represent all the bits as zeros. That is the starting location. That is the starting location. Okay, and ending location how you will get? If you place all the bits as ones, right? This is the starting address, and ending address you will get if you are representing all the bits as ones. All the bits as ones. Okay, now we already discussed, right, in the number system, binary to hexadecimal conversion. If you do the grouping of 4 bits, you will get the corresponding hexadecimal digits. Yes or no? That's why I told, even in the microprocessor also I will discuss the concepts of earlier chapter, right? That's why don't leave the session. Okay, here you will get 000H, 000H, and here you will get FFH. So for this particular RAM, okay, if you are starting all the bits from 0 and ending with all the bits as 1, this is the starting address and this is the ending address. This is the starting address and this is the ending address. But now in the question what they have mentioned, if the starting address is AA00H, 0000H, then what is the ending address? Okay, so if you're adding these two, that means you will get this number. Similarly, in order to get the ending address, what you have to do? You have to add these two numbers. Yes or no? In order to get the ending address, you have to add those two numbers, 0000H, and here we got FFH. See, in the starting chapter number systems, okay, we used to represent the number in brackets and will put suffix as the base of the number system. Okay, in the microprocessor chapter, we follow like this convention. Here H stands for hexadecimal. That's all. Okay, don't add these two H's. Okay, here H stands for hexadecimal. Now 0 plus F is F, 0 plus F is F. Here A is 10, F is 15. Okay, 10 plus 15 is 25. 25. So this 25, how you can write? 25 is the decimal number, but we want to represent in hexadecimal, right? So here we can write as 16 plus 9. This one we can write as 19. See, if you remember in the afternoon session we have discussed, whenever you are adding two digits of any number system, if you are able to represent with the single digit, obviously you can represent. Whenever the resultant sum exceeding the maximum capacity of that particular digit, obviously we require one more digit. This digit is nothing but carry. By default we will get one digit, that is the sum digit, and the carry, in the place of carry we always put 1, but the equivalent value of the carry is nothing but base of the number system, right? I hope it is clear. That's why I have told repeatedly, don't leave the session when I discuss about microprocessor, right? See here, the question is regarding microprocessor only, but for answering this question you require the concepts of first chapter only. Yes or no? Right? Yeah. So here you will get 9 as the sum and carry as the 1. A plus 1 is nothing but B. So that means B9FF. Option B is the correct one. B9FF. Option B is the correct one. Suppose, see, in this question they have given starting address like this and they are asking the ending address. Okay, that's why we have added. Now, suppose if they give ending address like this, then if they ask what is the starting address, then in that case what you will do? If they give the ending address like this and if they are asking the starting address, what you will do? You just subtract, that's all, right? See, here they have given starting address, that's why we have added this one with that one. Suppose if they give ending address, then from here you have to subtract this number so that you will get the starting address. Just opposite, right? Yes. Yeah. This is the question asked in gate instrumentation 2010. Here there is a bubble, just like here. Here you are having bubble, right? This is the CS bar. Just 1 second. CS bar. See, this is digital to analog converter. This is 2 to 4 decoder. Okay. Whatever the combination circuits, sequence circuits we will be having, right? Yeah, very good, Nikta. Very good. So whatever the combination circuits, sequence circuits we are having, right? All those circuits we can implement in the IC form, chip. IC, integrated circuit, in short we can call it as chip also, another name, right? So whenever we want to select the respective chip, okay, so that time we have to enable, right? So we have to select that particular chip. So for that we will be having the chip select signals, okay. Whenever at the input side you are having bubble, that time here you will get complemented. So that means whenever that particular input is 0, see, I already mentioned, if you are not comfortable at the input side, whenever there is a bubble, simply you can represent like this. Just put one inverter, that's all. Okay, if there is no bubble, if you are giving input as 1, that time chip selected. But whenever bubble is there, in order to get here 1, here you have to apply 0, simple. Okay. Now, for answering this question, you should have the knowledge of decoder, that's all. If you are having the knowledge of decoder, that is more than sufficient. See, What is the basic functionality of the decoder? What is the basic functionality of the decoder? Some students might be wondering that why I haven't discussed decoder concept in the combination circuit. Yeah, that is also important topic, but here I am touching that point. Okay. So the beauty of the digital circuit subject is from one chapter and another chapter are like linked one. Okay. So if you are constructing one building, right? So there will be number of floors, right? First ground floor, first floor, second floor, like that, right? So in the same way, whatever our digital circuits chapters are there, if you are strong on the first initial chapters, then you can solve the questions related to the higher chapters, right? So all these are interlinked. Yeah, that's why here, just to avoid the redundancy, I have touched the decoder concept here. What is the basic functionality of decoder? At any time, how many outputs will be 1? Here we are having 4 outputs. See, here they have mentioned bubbles. Okay, here they have mentioned bubbles. That means, okay, for the timing, if there is no bubble, for the timing, if there are no bubbles, that means based on here input code available, the respective output will be 1. Okay, but here you are having bubble, that means the respective output will be 0. Yes or no? But anyway, if you carefully observe, here we are having bubble, here we are having bubble. So these two bubbles will get cancel each other. It is simply like you are having 2 NOT gates. One NOT gate output you are giving as input for another NOT gate. So these two will get cancelled, right? Or simply if you are giving input as A, output you will get A bar, here A bar whole bar. That is nothing but A, right? So it is simply, you can say it is a buffer, or these two NOT gates will get cancel each other, or these two bubbles will get cancel each other. Okay, right. Now in the decoders we will be having the enable signal. Now the same decoder is available in the IC form, that's why we are calling it as a chip. So for enabling, the same thing, the wording in the combination circuits we will use enable signal, whereas in the whenever you are having the same circuits in the IC form, we will use the same enable signal only, we will represent as CS. Here CS indicates what? Chip select, simple. Okay. So here when the respective decoder is enabled, okay, based on the code available here, the respective output will be 1. Okay. So here if you carefully observe, you are having DAC, digital to analog converter. Okay. Here you are applying the digital input and you are getting the corresponding analog output. This particular digital to analog conversion will happen whenever this particular chip select is enabled. One second. Whenever this particular chip select is enabled. Okay, right. Now, in order to make this particular chip select as enabled, okay, here B2 value should be what? 1. B2 value should be 1 because these two are get cancel each other, right? These two bubbles will get cancelled. So if B2 is 1, that means this particular chip select is 1. Okay. So this digital data will be converted into analog. Now, in order to get B2 value as 1, okay, see here this is the most important thing. See, here we are having, with respect to microprocessor, we are having the address lines like this, A15, A14 and so on, A0. Okay, but okay, with respect to that, among A14 and A13, A14 is the higher order, but with respect to decoder functionality, among A1 and A0, A1 is the MSB. If you remember in the afternoon session I have mentioned, whenever they don't specify which one is the MSB, okay, I already mentioned, whenever you are having alphabets, starting letter is the MSB. Whenever you are having the numbering, higher order number will be the MSB. Okay, so don't get confusion. Okay, sometimes students will do the mistake that here actually B2 value should be 1. In order to get B2 as 1, A1 should be 1, A0 should be 0. 1 0 if you are giving as input, 1 0 is nothing but what? 2. So B2 value will be 1. Okay, but in general students used to do mistake that they will put 1 here, they will put 0 here with respect to microprocessor. No, we should not consider with respect to microprocessor. We have to consider with respect to decoder. Okay, with respect to microprocessor address lines among A14 and A13, A14 is the higher order. But here decoder functionality is what? Whenever the enable signal is activated, okay, based on the input code available here, accordingly the respective output will be 1. Okay, here in order to get B2 as 1, 2 is nothing but what? 1 0. So that means here you are having A1 A0. So that means A1 is the MSB. A1 is MSB. Okay, right. So these are the standard conventions regarding entire digital circuit subject. Okay, sometimes they will specify. If they specify, by default whichever variable is MSB, we have to consider. If they don't specify, whatever the conventions I discussed here in this session and in the previous session, please follow these conventions. Okay, right. Now here we got A15 value as 0, A14 as 0, A13 as 1. Okay, now here total we are having 16 address lines. Okay, so if you write those 16 address lines in terms of hexadecimal digits, we will get only 4 digits, only 4 digits we will get, right? So only 4 digits we will get. Just 1 second. Yeah. So here we will be having total 16 address lines or 16 address bits. When you do the grouping of 4 bits, you will get 4 hexadecimal digits, among which if you observe here in the entire circuit diagram, among all the address lines, here 15, 14, 13, based upon this one only the entire operation is depending on, right? Okay, so that's why for the time being I am considering the only the higher order bits A15, 14, 13, 12. Regarding remaining I will discuss shortly. Regarding 15, 14, 13, 12 I am focusing. Okay, right. So here 15 value is 0. Now 14 value is what? 0, 13 is 1. Okay, so these are mandatory for this entire circuit diagram. 15, 14, 13, these values should be mandatory. Now from A12 to A0, from A12 to A0, initial value can start with all the bits as zeros and final value you will get all the bits as 1. Okay, regarding A12 to A0 I am talking. Okay, so for the time being I am considering A12 is 0, minimum value, maximum value as 1. Okay, 0 0 1 0 0 1. So here 0 0 1 0 is nothing but 2 and 0 0 1 1 is nothing but 3. Okay, regarding A11 to A0, when you do the grouping of 4 bits, what you will get? The starting address you will get 000, 2000H, and the ending address you will get here the starting digit as 3 and the other 3 digits you will get FFF, right? Is it clear everyone? This is the address range. This is the address range for the given interfacing circuit, 2000H to 3FFF. Now the question is what? You have to identify the valid address. You have to identify the valid address. Within this range, okay, whichever option is satisfying, that will be the correct. Here 3000 is there, that will be the correct one. Yes, option A is the correct one. See, remaining if you observe, AFFF is beyond that range, 4FFF also beyond that range, C000 also beyond that range. Okay, sometimes they will ask the questions, you have to identify the address range, that means minimum value to max value. Sometimes they will ask what is the possible valid address. Sometimes they may ask among the given 4 choices which is not valid address, right? You have to read the question carefully. Based on the context, the answer will vary. You have to be very smart while attempting the gate questions, because whenever you are having MCQ type of question, right, for each and every mistake you are doing, you are getting negative marking, right? So you have to be very careful. You know the concept, okay, if you are good at concepts, definitely you will get whatever the solutions you are doing, definitely you will get correct. But most of the students, while choosing the correct option only, they used to do mistake, okay, because whatever the main keywords are there in the question, if you are not focusing, okay, definitely you will end with the wrong answer, right? So be careful, read the question carefully while you are attempting the question. Based on the context, the answer will vary, okay. Please make sure that you never do such type of mistakes, okay, in your real gate exam, right? So whatever with your hard work, whatever the marks you are supposed to get, at least let those marks with you, right? Don't lose even 0.5 mark also from your pocket, okay. So all these precautions if you do, definitely whatever the marks you are supposed to get, definitely you will get and you will be much more happy, right? When you are losing, then only, because whenever you are losing marks, obviously whatever your expected mark will be there, it will come down, right? So be careful, try to avoid these type of mistakes. Only thing, if you are having the patience and if you carefully read the question, then definitely you can attempt the option correctly, attempt the question with the correct option, right? That is a very, very important. Option A is the correct answer for this question. Yeah, with this we have completed regarding microprocessor. So very happy. So today all of you got 2 slots for attending entire digital circuit subject. Most of the important topics we have covered in the earlier session and in this session. So first of all, I am thanking all of you for having the patience and actively participated in the earlier session and in this session, right? So if you are having any doubts, you can ask now. If you don't have any doubts, you can just mention in the chat that it is everything clear. Okay, so that I will start the quiz now. All of you please respond. If you are having any doubts, you can ask in the chat. If you are not having any doubts, if everything is clear, whatever I have discussed in this session and earlier session, so please mention in the chat it is clear, so that I will start the quiz, so that this is the right time you can check your confidence level regarding digital circuit subject. Whatever we have discussed in the earlier session and in this session, regarding all these topics only, we are going to conduct one quiz now. Yeah, Nikita is having one doubt. In the Mealy state, please explain the non-overlapping. Okay, right. Yeah, this is regarding Mealy state machine. You are asking regarding non-overlapping. Okay. So regarding non-overlapping, say for example, you are having the bits like this 101, 0, 101. Suppose if you are having like this, one sequence of bits like this. Okay. If it is non-overlapping, okay, then here you are having 101, so output is 1. Okay. Now, non-overlapping means you have to start once again the fresh sequence 101. Here you will get output as 1. If the detector is detecting the bits with overlapping, in that case here also you are having 101, so here also you will get 1. Okay. But since you have asked for without overlapping, if you are sending the bits like this only 2 times the corresponding bit, so only 2 times you will get output as 1. Only 2 times output as 1. Okay. Up to this point, is it clear, Nikita? Regarding the difference between with overlapping and without overlapping, whether this particular example is clear? Yeah. So if it is clear, now in the state diagram it is very simple. See, in the state diagram, this particular state diagram, what it is detecting here, from state A to state B, if you are receiving 1, your state transition happening, right? From state B to state C, transition happening if the input is 0. From state C to state B, the transition happening if the input is 1. So that means if you just focus only the inputs, 1, 0, 1 you have received. Okay, here output is 0, here output is 0, here output is 1. So that means output you got as 1 if you are receiving the bits as 1, 0, 1. Okay, now from here if you are continuing the process with respect to this diagram, so this 1 is the ending sequence. This 1 is the ending sequence for the first 3 bits, 1, 0, 1. Okay, that 1 can be the starting sequence for my next one. Okay, so in that case 1, 0, once again 1, so I am getting 1. So this is the example for overlapping. Now if you want to make the same state diagram for non-overlapping, okay, instead of drawing the line from C to B like this, make the line from C to A. So that means, say for example, that case what will happen, just carefully observe, here you have received 1, here you have received 0, after that what I am doing, from C to A only I am making line. Okay, 1, 0, 1, 1, 0, 1. So that means one sequence over like this, you got output as 1. Now you are sending bit value 0. When you are at state A, if the input is 0, you will be at the same state only. Okay, now after that you have sent 1. That means from state A to state B will happen. Next 0, state B to state C will happen. Next 1. So that means from state C to state A will happen. I hope it is clear now. Without overlapping means this line instead of C to B, you have to draw from C to A. Any other questions? Yeah. Okay, let us start the quiz, and if you are having any other doubts, okay, after end of the quiz also I will clarify all of your doubts. Okay, if you are having any doubts, please make a note. All of you be ready for the quiz. Okay, for each and every question, here we are having total 20 questions. Okay, for each and every question I will give some time. Okay, the moment you are solving the question, whatever the answer you are getting, please respond in the chat. Okay, if you are able to get the correct answer, then I won't explain that question, I will move to the next one. Okay, I will show the next question, you can try to solve. Wherever, in whichever question you are facing the difficulty, or if you are getting the wrong answer, you can just mention in the chart, so that question only I will explain. Okay, is it clear regarding this quiz? This is only for testing your knowledge and just to know your confidence level regarding this particular subject. See, for whenever you are learning anything, there will be theory and there will be practical, right? So once if you are good at practical, then you will come to know that you will be very much happy, right? So up to now whatever we have discussed in the earlier session, this session is just like theory. Of course you understood everything, I am very much happy whatever the concepts I have discussed here, but now I want you to attempt the questions and you should get correct answers, right? That is also most important, right? Don't get worried even if you are getting some questions wrong answer, I am here to clarify, and wherever you done the mistakes you can rectify. Okay, right? Please be peaceful and no need to take any tension. Okay, just peacefully you can attempt, right? Okay. Yeah, this is the first question. The octal equivalent of the hexadecimal number is. All of you try to solve these questions, and one by one, one by one question I will show on the screen. After solving the question, what are the answers you are getting, please mention in the chart. And whenever I mention the correct answer, after that just count how many questions you got correct. Okay, just make a note so that at the end of the session, okay, how many you got correct, you can mention that number. Out of 20 questions, how many you got correct. That will give you the boosting for yourself, because whatever you have attended, the previous session 3 hours and in this session 3 hours, right? So this 6 hours together, it should be very much worthy for all of you, right? Yeah. Yeah, very good, Aswin. Yeah, Nikita is getting option E. No, just be careful. Huh? See here what they have given hexadecimal number. Okay, they are asking the corresponding octal number. So first what you have to do, you have to convert hexadecimal to binary. So each and every hexadecimal digit you have to represent with 4 bits. A is nothing but 1010, B is nothing but 1011, radix point, C is nothing but 1100, and D is nothing but 1101. Now we have to do the grouping of 3 bits in order to get the corresponding octal number, right? So here 110 is nothing but 6, 011 is nothing but 3. Here 01 you are having, you have to put this bit as 0. So then you will get 2. And regarding this one, okay, 011 is nothing but 3, 101 is nothing but 5, and here you can put simply 0, 010 is nothing but 2. So that means 253.632, this is the corresponding octal number. Option B is the correct one. Okay, actually for answering this question, if you look at the 4 choices, just observe 1 digit to the left of the radix point, 1 digit to the right of the radix point. In all the 4 choices you are having different, right? 3.3, 3.6, 6.3, 6.6. Just if you are able to calculate these two, that is more than sufficient in order to choose the correct option, right? 3 and 6, right? So whenever you are having MCQ type of question, just look at the options. Okay, from there you will get the clue. At what step you can stop the process in order to choose the correct option, right? Yeah, very good, Nikita. Meghna, yes, very good. Next question. They have given one octal number. They are asking the equivalent one you have to find out. Yes, very good. Option B is the correct one. Correct. Option B is the correct one. This is the octal to hexadecimal conversion. Okay. Next question. Here you are supposed to find the base. They have given one equation like this. They are asking the corresponding base. Three one two divided by 20 equal to 13.1. So whenever they don't mention what is the base, you can assume any letter. If you want, you can assume letter B or letter R or X. Any letter you can use. Sometimes they will specify in the equation, sometimes they won't specify. You can assume any base. That means unknown you can represent with any letter, I mean to say. Yes, very good Nikita, very good. Have you solved, Nikita, this question? Whether conventional approach or shortcut? Yeah, Aswin, very good. Yeah, you have solved conventional approach. Okay, right. I will give the shortcut method. Okay, after this question, we are having similar question. Here also you are supposed to find the base or radix. All of you try to solve this question. After that, I will explain by using shortcut method. Whatever the concepts we have discussed in the previous session, this session, I have kept the quiz questions in the same order, so that it's kind of revision, I can say. Whatever so far we have discussed, okay, at the end of the session, I am giving the glimpse of or overview of whatever we have discussed, like capsule, you can say. If you are facing any difficulty regarding any question, please mention in the chat so that I will explain. Okay, don't worry. First, I will give time for you to solve voluntarily, but if you are facing any difficulty for any question, you can mention in the chat. Don't feel bad. I am here to clarify. Okay, I will explain. Yeah, very good, Aswin. Very good. Yeah, very good, Nikita. Yes, option C is the correct one. Okay. First, I will explain this question by using shortcut method. Okay. Yeah, very good, Meghna. Very good. So, in the morning, in the afternoon session, we have discussed one question related to finding base only. There, if you observe, on the left hand side you are having addition of two numbers, and right hand side you are getting resultant value. So there I have told is what, just perform the addition by considering those two numbers as a decimal, right? In the similar way, here they have given ratio of two numbers equal to something else, right? So this one second. So this one you can write like this, right? 312 base b is equal to, just multiply these two, 13.1 into 20. Okay, ratio of two numbers equal to something they have given. What I have done, I have modified as multiplication of these two numbers equal to this one. Okay, just multiply these two numbers by treating these two as the decimal. By treating these two as the decimal, what you will get? You will get 2, 6, 2, and here you are having 0. We have to put the radix point after one digit, so this 0 we can neglect. So that means what? You are getting 262. You are getting 262 base b. But this number is not matching to this one. So that means obviously base value is not equal to 10. It will be something else, right? Okay, right. So here digit is 2, here also digit is 2. Both are same. No need to do any manipulation. Now carefully observe. Here you are having 6, here you are having 1. Both are not same. Both are not same, right? So this 6 you can write as, here already you are having one digit as 1. By adding with which number you are getting resultant value as 6. That will be your base. Yes or no? So here 5 is the base. By adding with which number you are getting resultant value as 6. That is nothing but base. So the answer for this question is 5. Okay, right. Now follow the same thing, shortcut method here. Here you are having square root of this number equal to this one. Okay, this one we can write like this, 224 base r is equal to square of this number, 13 base r whole square. Square root of this number equal to this one. If you do the squaring on both sides, you will get like this. Okay. Now for the time being, consider this number as decimal. If you are performing squaring of this number, what you will get? You will get 169 and 169, 224. Both are not same. Both are not same, right? So here you are having 9, here you are having 4. Whenever the digits are not same, do the manipulation. Okay. So this 9 we can write as, you already know the other digit as 4, right? So by adding with which number you are getting resultant value as 9, that is nothing but your base. So option C is the correct one. Okay. So in this way you can solve related to base or radix. Whenever you are supposed to find, you can solve by using these shortcut methods. Okay, so that you can solve the questions in less time. Okay, of course if you want you can do with the conventional approach, no problem at all, but only thing, it will take more time. Okay, right. I hope it is clear regarding the shortcut methods. In the morning session, in the afternoon session I have discussed regarding addition of two numbers. In the previous question I have discussed multiplication of two numbers, here square of a number, right? All the three questions I have discussed with the help of shortcut only. Okay, right. Yeah, next question, this is related to 2's complement form. Yeah, these lectures will be available. Okay, even after the live session it will be available in our channel. You can check the link and you can click on the link, like button. Okay, you can save in your likes. Okay. All of you please share this video link and the previous session video link with all of your friends, so that those who miss these sessions for attending in the live, okay, so they can watch in the offline later also, okay, so that they also will get benefited from these two sessions regarding digital circuit subject. Yeah, very good Meghna, very good. Yeah, option C is the correct one, correct. Yeah, very good Ashwin. So here this question based on sign extension property and regarding what is the shortcut we have discussed, okay. So if you apply both the methods, then you will get the answer easily. Okay, just observe option C. This entire number equivalent value is same as this number. This entire number equivalent value is same as this number, right? So now you just put the position weights: 2 power 0, 2 power 1, 2 square, 2 power 3, 2 power 4, 2 power 5. 2 power 5 is nothing but 32. Since sign bit is 1, I will consider minus. Minus 32 plus 4, that is nothing but minus 28, right? Yeah. Yeah, this is a dead easy question related to simplification of Boolean functions. Yeah, Nikita, you can cross check. You almost come closer to the answer. Just be careful with the complement symbol. Yeah, very good Ashwin, very good. Option D is the correct one. See, from these two you can take x bar as common, then y bar plus y is 1 and write the middle term. Now you can apply distribute law, right? X bar plus x is 1, so you will get x bar plus y, x bar plus y, right? By using distribute law. Yes, very good Meghna, very good. Next question, this is also related to simplification only. Whenever you are supposed to find the simplification, always try to observe the common terms. If there is a possibility of taking common, better take, so that your simplification will become easy. Yes, very good Nikita, very good. It is a simple question only. Okay, just take Q as common. After that, wherever possible, apply distributed law. From there, you will get option A is the correct one. Next question. This is also a very simple question. Yeah, very good Meghna, Ashwin. This is also a simple question related to simplification of Boolean function. In one sense it is simple, but you have to be smart while choosing the correct option. Some students may face difficulty even though it is a simple question in order to while choosing the correct option. Are you facing any difficulty? Is it simple question or complicated? Whatever the important laws that we have discussed, just apply those laws. That's all. Whichever laws are applicable, just apply. What is the option you are getting for this question? Yeah, Abhishek is getting option A. No, it's not correct. You done somewhere mistake. Yeah, see, just observe here. You can apply De Morgan's law here. X bar plus y bar. X bar plus y bar. You can write as xy whole bar. Okay. Into z plus xy. Okay. Now, if you observe carefully, it is something like a plus a bar b, where a is nothing but what? xy. So, a plus a bar b is nothing but what? A plus b. So, that means what you will get? xy plus z. So, from here to here I have applied distribute law only. Okay. But unfortunately, you don't have such option in the given choices. But you will get the correct option if you apply once again distribute law from RHS to LHS, right? So, yeah, from LHS to RHS only. Okay, z plus y into z plus x. Z plus y into z plus x. Okay, right. So here if you observe option C you are having. Okay, so 2 times you are applying distribute law. Yeah, very good Aswin, very good. Is it clear Abhishek? Meghna? Here I have applied De Morgan's law, after that I have applied the distribute law, that's all. And here once again I have applied distribute law. A plus A bar B is equal to A plus B. Similarly, z plus yx equal to z plus y into z plus x. Right? Yeah. Yeah, next question. Try to simplify this one. All of you try to simplify without using pen and paper. Without using pen and paper, try to simplify. Just contemplate, you will get the idea. Without using pen and paper, you can choose the correct option. All of you actively participate. Whatever the options you are getting as the correct, please mention in the chart. Don't hesitate that sometime if you are getting wrong answer, no problem. Don't worry. Yes, very good, Meghna. Yeah, very good. Option D. Yes. See, most of the students used to do the simplification by using De Morgan's law. Of course, you can do the by applying De Morgan's law. Also, you will get the same answer. But if you remember in the previous session, I have mentioned whenever you are supposed to find the complement or whenever you are having the complement of a particular function, okay, before applying De Morgan's law, I have told one thing. Just observe under the complement, whatever the expression you are having, whether we can do the simplification or not. If there is a possibility of doing simplification, first do it, so that you will get the answer very quickly. Right? Just carefully observe. Here, what you are having? Among all the variables, you are having logical or only. Right? So, b plus b bar is what? 1. 1 plus anything is 1. Complement of 1 is 0. Right? Option D is the correct one. Next question, this is related to K-map. They have given one K-map and they are asking the simplified expression. Simplified expression. Yeah, very good Nikita, very good. Yes, very good Meghna. Yeah. Option B is the correct one. Option B is the correct. See, whenever they give the K map in terms of ones and zeros, whether you do the simplification with respect to ones or with respect to zeros, final answer will be same. Okay, right. So if you carefully observe, you can do the grouping of these 4 ones. So here you will get A value as 1, so that means A, and you can do the grouping of these 4 ones. Okay, so from this grouping, column wise, C value is 0, that means C bar. See, whenever you do the grouping of min terms, you will get product terms. After that, what we will do? We will sum together. So that means A plus C bar, A plus C bar. Okay, right. So see, here you are having ones, other than ones you are having zeros. So if you do the grouping of these 2 zeros, that means whenever you do the grouping of zeros or max terms, you will get the sum term, right? Here row wise A value is 0, that means A, plus column wise C value is 1, that is C bar. So here we are having only one grouping, so that's why you will get sum term, right? So either you can do the grouping with respect to ones or with respect to zeros, you will get the final answer is same. Okay. Next question, this is related to logic gates. Here in order to get the output as 1, they are asking the condition for inputs. Yeah, very good, Aswin. Option D is the correct one. Yes, very good. See, here you are having exclusive NOR gate, exclusive NOR gate. So whenever you are having exclusive NOR gate, in order to get output as 1, the condition for number of ones is what? Even or odd. Here at the input side, you should have even number of ones. If you are having even number of ones at the input side, then XNOR gate will produce output as 1, right? Okay. Now, if you carefully observe, here you are having XOR gate, here XNOR gate, inputs are AB, inputs are AB. So these two are complement to each other because both the inputs are same, both the inputs are same for these two gates, right? So either suppose if you are getting 1 here, then you will get 0, or if you are getting 0 here, then you will get 1 here. Either like this combination you will get or like this combination you will get. Whatever may be the input condition you can apply. Either 0, 0, 0, 1, 1, 0, 1, 1, whatever may be the number of whatever may be the combinations you may apply, you will get among these two outputs at one place you will get 1. Okay. But what is the condition here? If you are having even number of ones, then only you will get output as 1, right? So here either here or here we are getting single 1, right? So in order to make here number of ones as even, so we have to make C value as 1, right? So if you look at all the 4 choices, only one option you are having C value 1, right? So that's why obviously this option will be correct. But if they want to frame this particular question as MSQ, okay, they can give 4 choices like this. They can keep C value as 1 in all the 4 choices, okay. In all the 4 choices they can keep C value as 1. Regarding AB values, okay, in option A they can give 0, 0, option B 0, 1, option C 1, 0, option D 1, 1. Then you have to choose all the 4 options. Then this is the MSQ type of question. In that case, all the 4 options will be correct, right? Yeah, next question. This question is also related to logic gates. You have to find the output expression. Yeah, very good, Aswin, Abhishek, Nikita. Simple question only, right? Try to get the whatever the option you are getting, just mention. Yeah, Meghna, you almost come closer to the answer. See here, you are having the inputs as P, Q, but here you are having inverter, so that means Q bar. Here you will get PQ bar whole bar. You are having two input NAND gate, right? PQ bar whole bar. Okay. Then here another input is Q. Here inputs are QR. So that means you will get QR whole bar. Okay. Whenever you are having the circuit which consists of same type of gates, don't do the, here in this particular example you are having NAND gate, right? So don't do the simplification here. Of course you can do, but you are unnecessarily making the simplification procedure complicated, right? So here if you observe Z is nothing but you are having three inputs, right? So just consider by default you will get complement. Here you are having three terms, PQ bar whole bar, and second term is Q, and third term is QR whole bar. So now when you apply De Morgan's law, each and every term will get complemented. So that means first term complement, 2 times complement means you will get the same function, then Q bar, then here QR. Okay. So from these two you can take Q bar as common, 1 plus anything is 1, logical OR. Once again distributed law, Q bar plus Q is 1, so you will get Q bar plus R. So that means option C is the correct one. Yeah, very good Aswin, Meghna, option C is the correct one. Yeah, this is the question related to flip-flops. It seems to be complicated, but if you carefully observe the circuit diagram, you can solve this question just like that. Just recollect regarding logic gates. If you are able to identify this circuit, just identify. Can you give the name of this particular circuit? Here you are having 4 NOR gates. What is this particular circuit? Can you identify? If you are able to identify this circuit, this question is nothing. You can solve this question without using pen and paper. Yeah, very good, Aswin, very good. This is XNOR, correct. If you are having here 4 NAND gates, then it will become XOR gate. Here you are having 4 NOR gates, so this is XNOR gate. XNOR gate followed by inverter. This is NOT gate. You are having NOR gate, but both the inputs are same, so that means it is acting as NOT gate. XNOR followed by NOT is nothing but XOR gate. Overall combination you are getting XOR. Instead of directly representing one gate XOR, they have given the circuit diagram like this, that's all. Yeah, very good, Nikita. No, Devrat, it's not half adder. Yeah, in the half adder you will be having sum expression and carry expression. Okay. So regarding carry you require AND gate, regarding sum you require XOR gate. So up to this one you can say that is the sum equation of half adder, right? Yes, very good, Nikita. Option C is the correct one. See, here you are having D flip flop, Q of t plus 1 equal to D. Whatever the D input you are having, you will get as the next state, right? So here this entire circuit diagram is nothing but XOR, and here you are having AB, one input is AB. For this entire XOR gate you are having 2 inputs. One input is AB, A and B. Another input is what? Q. Another input is Q. So now if you consider this one, A equal to B equal to T, then Q of t plus 1 you are getting T XOR Q. So that means it is a T flip flop if A and B are equal to T, right? Yeah, I hope all of you will attempt this question without using pen and paper. Yeah, very good, Devrat. Yeah, don't worry whenever you are doing any mistake, okay, where you done the mistakes, please note down somewhere. So all these will be what? Learnings for you, okay. So from each and every mistake you can learn something new, but don't do repeated mistakes, okay. If you are doing repeated mistakes, that means you are not learning anything new, okay. You are simply doing like that, okay. So learn, do as many mistakes as possible, but don't repeat the same mistake, okay. That is very, very important. The more you do the mistake, that means the more you are learning, that means you are advancing your knowledge, concepts, each and everything you are advancing, okay. If you are not doing single mistake, that means you are not learning anything at all, you are not learning anything, okay. We are not ideal persons, right? We are the human beings, okay. We used to do mistakes, okay. If you are not doing mistake, means only 2 possibilities: either we are we are the lords, or another case is we are not learning anything, ideal, either ideal or ideal. Okay. So here the question is regarding mod 258 counter. You are having mod 258 counter. For designing this one, what is the minimum number of D flip-flops required? Yeah, very good, Nikita, Meghna. Yeah, 258 is the correct one. See, whenever the term D flip-flops mentioned, the respective counter can be only two possibilities. Either it can be ring counter or it can be Johnson counter. It can be ring counter or it can be Johnson counter. Just recollect the concepts whatever I have discussed regarding ring counter and Johnson counter. Here they haven't mentioned whether it is ring counter or Johnson counter, but they have given the clue. Here you are using in this counter D flip-flops. Whenever they are mentioning D flip-flops, that means the respective counter can be either ring counter or Johnson counter. In ring counter, the number of states, number of flip-flops, number of bits all are same. Here 258 is what? Number of states. Okay. So in the ring counter, the number of flip-flops required is 258. Number of D flip-flops we require is 258. Okay. So if you observe among the choices, here we are having 258. Okay. So obviously that will be the correct one. See, in the Johnson counter, just carefully observe. In the Johnson counter, you will get the number of flip-flops as what? Half of the total number of states. So that means here 129 you will get. See, in this particular given choices, you don't have 129. You don't have 129. Okay. If you are having 129, obviously that will be the correct one. See, sometimes students may do the mistake. Okay. Here instead of dividing, they may do multiplication. See, always remember, in the Johnson counter, the number of flip-flops required is what? Half of the number of states. So here among 258 and 129, they have given 258. So that's why that is the correct one. If they give 129, 258, then obviously you have to choose 129. Okay, right. Yeah, next question regarding ripple counter. Yeah, thank you, Devrat. So these are the simple questions regarding counters. All of you try to attempt without using pen and paper. Just use your brain now, so that you can get answers quickly in less time. If you are using pen and paper, of course definitely you will get the answer, but it will take more time. If you be smart, okay, don't work hard, be smart, work smartly. Wherever there is a necessity of pen and paper, that time only use. Rest of the time better use your brain, mind, so that your IQ level you can increase, right, and you will be more and more active. Yes, very good, Aswin, very good. See, everyone can answer this question just like that. Just 1 second. See, here you are having mod 10 ripple counter. See, whenever in the counter if they mention ripple, that means what? It is a binary counter. And here they already mentioned the number of states. So here number of states are 10. Whether that counter can be up counter or down counter. Okay. Whether you consider up counter or down counter, the maximum count that you can count is 9, because it will start from 0 to 9 or 9 down to 0, right. So for represent 9 you require 4 bits, so that means obviously you require 4 T flip-flops. Okay, so that is the basic difference between ring counter, Johnson counter and asynchronous counter or ripple counter. Okay, in the ring counter and Johnson counter we are using D flip-flops, that's why we are unable to get all the states. Whereas in the ripple counter, we can get all the states starting from 0 to maximum whatever. Okay, but in this case they mentioned only mod 10, so that means it will count up to 9 only. Okay. Next question, this is a dead easy question. A cascade of 3 identical mod 5 counters. You are having 3 mod 5 counters in the cascading format, and they are asking overall modulus. They are asking overall modulus. Yeah, very good, Nikita. Answer is option C. See, it is very simple. You are having 3 mod 5 counters in the cascaded format. So, at first stage you will get f by 5, that is the clock signal frequency for next stage. So, that means f by 5 divided by 5, that is nothing but f by 25. And for third stage you are giving as a clock signal as f by 25. So, f by 25 divided by 5, that is nothing but f by 125. So, whenever you are having mod n counter, so the output frequency will be what? F divided by the number of states. Here 125 is corresponding to the number of states. So, that means overall modulus will be 125. Yeah, all of you try to attempt this question carefully. Try to attempt this question carefully and please share whatever the answer you are getting. Just mention the answer in terms of binary, 4-bit binary number. This is the question number 17. We are having 3 more questions. Okay, we will try to complete the quiz in couple of minutes. I know that most of you are eagerly waiting for dinner, but whenever, okay, you are not having the dinner, so when you are about to have the dinner, that time your mind will be more active. Okay, yeah. So definitely you will get correct answers. Yeah, very good, Ashwin, Chandu. Yeah, very good. See, here they have mentioned mod 16 down counter. Underline this word, this is very important. If you recognize this word, okay, then you will get the correct answer, damn sure you will get the correct answer. Okay, here they have given initial state like this. After applying 37 clock pulses, what is the state of the counter? Okay, so at 0th clock pulse, what is the state you are having? At 16th clock pulse also same thing, at 32nd clock pulse also same thing. After that you have to apply 5 more clock pulses. Okay, since they have mentioned down counter, okay, so this particular value will be decremented by 1 for each and every clock cycle. Here 0110 is nothing but 6, so you have to apply 5 more clock cycles. So for each and every clock pulse, the counter value decremented by 1. 6 minus 5 is nothing but 1. So the corresponding binary is what? 0001 regarding 4-bit case. Okay, but in general in the exam, most of the students they won't focus that much about this particular term, right? So they will consider up counter. So here you are having 6, they will add 5. So that means they will get 1011, 11. Okay, but that is wrong. That will be correct if they mention up counter. Okay. Next one, question number 18. This is the question related to finite state machine. Just 1 second. Yeah. So this is the real time based question regarding finite state machine. So we are having the traffic light control system. So we will be having 3 lights, right? Green, yellow, red. These are the 3 lights we will be having. Okay. So here green is turned on for 70 seconds and red is, one second, yellow is turned on for 5 seconds and red is turned on for 75 seconds. We are having 3 lights, green, yellow and red. Each light will turn on for certain duration. Okay. And they have mentioned for this particular system or finite state machine, they are giving clock signal period as 5 seconds. 5 seconds. And now if you want to realize this particular circuit by using flip-flops, what is the minimum number of flip-flops that are required for implementing this FSM? Just apply your common sense, then you will get the correct answer. Apparently you may think that this sort of question we haven't covered in our discussion, but for answering this question, whatever the knowledge is required, I have already covered. Only thing is you have to visualize, that's all. Regarding counters, we have discussed in one fashion. Okay, FSM is nothing but just it is another representation for the same sequence circuit. Just understand whatever the given statements are there, just apply the common sense, you will get the answer. Yeah, very good, Aswin, very good. 5 is the correct answer, very good. See, just recollect the counter concept. What is the counter concept? You are having some number of states, those states only will get repeated, right? Okay. So here this is the traffic light control system. Here we are having 3 lights, green, yellow and red. Okay. In order to complete one cycle, what is the amount of time it is required? Here 70 seconds, 5 seconds and 75. Just add all these 3, 70 plus 5 plus 75. So you will get 150 seconds. So in order to turn on green, yellow and red for one time, it takes 150 seconds. 150 seconds it is taking. But for this particular system, we are providing the clock signal which is having only 5 seconds period. Only 5 seconds period, right? So here the total time, here total time is, see, if you want I can represent like this. Say for example, for completing overall one cycle, that is NT divided by time period of the clock signal. See, here you are getting 150 seconds and time period of the clock signal is 5 seconds. So if you do the cancellation from here, you will get n value as 30. So that means number of states are 30. Number of states are 30. Okay. So here if you observe, they are asking minimum number of flip-flops. Okay, they haven't mentioned what kind of flip-flop it is. Whenever they don't mention what kind of flip-flop it is, and here one more clue, what kind of flip-flop you have to choose. If you recollect ring counter, Johnson counter and asynchronous counter, among those obviously the number of T flip-flops will give the what? Minimum number, right? So whenever they specify like this, obviously you can take what? Flip-flops, T flip-flops only. Okay. If you are considering D flip-flops, always the number will be more only when compared to T flip-flops. And one more thing, if you observe, here they have mentioned FSM. Finite state machine is nothing but synchronous sequence circuit only. So in the sequence circuit, we will use T flip-flops only. Okay, in the synchronous sequence circuit also. But in the gate syllabus, whatever the concepts we are having regarding ring counter and Johnson counter, we are using only D flip-flops. Okay, whereas regarding binary counter, we are having only asynchronous counter. Okay. Similarly, if you want, you can design with T flip-flops the synchronous counter as well. But only the problem is the circuit may become complex, but the circuit will respond faster. If you want more speed, that means you have to bear for the cost of the circuit, right? So it is a kind of trade-off, right? So from this FSM also you will get the clue, that is you are using T flip-flops. Okay. So here whether you consider up counter or down counter, if you are having 30 states, maximum count that you can count is 29, 0 to 29 or 29 down to 0. For representing 29, how many bits you require? For representing 29, how many bits you require? 5 bits. So obviously we require 5 T flip-flops. 5 T flip-flops. Okay, the answer for this question is 5. Yeah, this is the question related to microprocessor interfacing. Here they are asking total size of the memory system. Here you are having 8 memory chips. Each memory chip is having 12 address lines and 4 data lines. So each memory chip is having 12 address lines and 4 data lines. Like that you are having 8 memory chips. So what is the overall capacity? I already given the formula. Just use the standard formula and you will get the correct answer. Whatever the formula we have discussed, that is only for one memory chip. Here you are having like that 8 memory chips. Just you have to multiply with 8. Nikita, please cross check. You are almost closer to the answer. See here you are having, whenever you are supposed to find the memory capacity, the standard formula is 2 power n by m. But here you are having like that 8 memory chips. So 8 into 2 power, here number of address lines are 12 and number of data lines are 4. And here if you observe all the choices in terms of kilobyte, okay. So this one I will rearrange. 2 power 12 I will write as 2 power 10 into 2 square, and here we are having 4 and this 8 I am writing here. 2 power 10 is nothing but kilo, group of 8 bits is nothing but byte. Okay. So here 4 into 4 is 16. So that means option A is the correct. Option A is the correct one. Yeah, very good Devrat. Option A is the correct one. See, based on the units, accordingly you have to represent. Simple. Here you are having capital B. Capital B indicates what? Byte. Byte is nothing but group of 8 bits. Capital K is nothing but 2 power 10. That is nothing but 1024. Okay. So just do the arrangement like that. If you don't have 8 memory chips, then this is the formula. But here they have mentioned 8 such memory chips you are having. That's why you have to multiply with 8. Yeah. I hope all of you are enjoying this quiz. So last question we are having. This is the last question regarding memory interfacing. I hope all of you will attempt this question correctly. Here they have given a RAM size like this and they have mentioned the last memory location as 4FFF and they are asking the starting memory location. I hope everyone will get the correct answer for this question. This is the last question for this quiz. Previously we have discussed one question. In that question they have given the starting address, they have asked the ending address, but in this question they have given the last address, they are asking the starting address. Yeah, Meghana, please cross check regarding the starting digit. Yeah, Ashwin, very good. Option C is the correct one. See here, you are having number of memory locations are what? 8k. 8k we can write as 8, you can write as 2 power 3, 1k, k we can write as 2 power 10. So that means here we require 13 address lines. 13 address lines or address bits. Okay, right. So now you consider the 13 address bits. But whenever you do the grouping of 4 bits, you will get the corresponding hexadecimal digits. So here 12 bits we are having. So 13 bit I will consider like this. Okay. If you do like this representation carefully, then obviously you will get the correct answer. Okay. If you do the wrong way representation, then you may end with the wrong answer. Okay, right. So now if you represent all these bits, starting bit with 0, then you will get the starting address, and if you are continuing like this, ending address will be all the bits will be 1. Now when you do the grouping of 4 bits, you will get the corresponding hexadecimal digits. Here 000 you will get regarding these 3, and here whenever you are doing the grouping of 4 bits, okay, if other bits are not there, whenever they don't give any information regarding the other bits, you can simply assume 0. Sometime whenever they give the interfacing circuit, okay, regarding those unused bits, sometime they will specify. Okay, if they specify some value, you have to fixedly you have to consider that one. Whenever they don't give any information regarding the unused bits, simply you can put zeros. Okay, so if you are considering zeros, then from here we will get 4 zeros. Okay, and here 000 if you are considering, then 1 FFF you are getting 1 FFF. Okay, so this is the starting address, this is the ending address. But in this question they have given ending address as 4 FFFH. Ending address they have given 4 FFFH. And now you got the ending address like this, 1 FFFH. So here we have to do simply subtraction, that's all. So you will get 3000H. So that is the option C. Option C is the correct one. Previously we have discussed one question. There they have given starting address, they asked ending address. That's why we have done addition. But in this question they have given ending address, they are asking the starting one. So you have to subtract this last address from this one, so that you will get 3000H. Yeah, all of you just please count out of these 20 questions how many you got correct. For how many questions you got correct. Just quickly count and mention the number of questions for which you got correct. don't hesitate in mentioning the number of questions correct in the chart. Please be honest. Already you got the gifts, right? Okay. So here no need to worry. Just mention for how many questions you got correct. Yeah, very good, Aswin. 16 correct out of 20. Very good. Meghna and Nikita. Others also please mention how many you got correct out of 20. Don't hesitate in mentioning the number. Yeah, Meghna got 14, very good. Yeah, Nikita got 12. Okay, nice. Yeah, just please share your experience regarding this quiz and regarding these two sessions. Just please share your experience, how you felt. Yeah, wherever you done the mistakes, okay, please note down. Okay, so those will be the learnings, right? So definitely these two sessions play a vital role for all the students who are from EC, electrical, instrumentation and computer science, okay, because in these two sessions we have covered most of the important concepts, okay, regarding digital circuit subject, and we have covered not only with respect to concepts, with respect to good number of models also, right? It's a kind of revision, so for all of you. So please share these two video links with all of your friends, okay, and subscribe our channel and click on the bell icon in order to get the instant notifications, okay. If you are having any doubts, you can ask now. If you are not having any doubts, if everything is clear, then you can mention in the chart it's clear. Thank you everyone for your cooperation. Actually, we extended the session half an hour, right? Thank you everyone for your cooperation. I hope everyone liked these two sessions and got most of the knowledge from the digital circuit subject. And not only that, I hope that all of you got the confidence about this particular subject. No matter whatever may be the level of the question in your real GATE exam, you will be in a position to attempt the questions from the digital circuit subject, and not only that, you will get the correct answers, okay. Yeah, thank you Nikita, thank you. Thank you everyone for attending these two sessions, and hope you liked these two sessions. Yeah, thank you everyone. Once again, happy Engineers Day for all of you.